Hello everybody, I hope you're doing well. Today I'm going to be showing you how to create this Molotov cocktail effect in Houdini. Let's get into it. Before we start, I just wanted to say a couple of things. First of all, thank you for your patience. I know it's been a little bit since the last video, but I have been very busy with freelance. And second of all, you're going to have to forgive my voice in this tutorial. My throat is a little bit short, but I really wanted to get this tutorial out to you guys. I also wanted to say that in this tutorial I will be using Axiom. However, I did prepare a project file that uses no Axiom or third-party plugins, and it uses the default Pyro solver, so that's available for free. There's no catches, as always, in the Gumroad in the description below the video, so you can follow along even if you don't have Axiom, and I recommend that you do because you'll learn a few techniques. Alright, let's get into it. So the first thing we're going to want to do is set up a bottle that we can smash. So I'm going to drop down a geometry container and name it bottle smash, just to make sure we keep everything nice and tidy. And I'm going to hop inside of that, and inside here we're going to drop down a file. And I'm going to go ahead and I'm going to go to this directory and get my bottle. You'll find this bottle in the description, and you'll also be included in the project file as well. So naturally the bottle comes in quite large. It's pretty massive. So what we're going to do is we're going to drop down transform, and we're going to scale this down a little bit. I'm going to scale it down to like 0.15. You could scale this down to an accurate bottle size, which would probably be like 0.05 or 0.005. It's probably more accurate if I drop down a simple, like a mocap biped. Well, that one's probably a bit small, so probably 0.05 is like, yeah, oh, no, it's probably like an in-between. Sometimes to find the scale is a little strange. It's normally 0.05 or 0.005 or 0.02, like 0.01, but we're not going to do this exactly to scale for a couple of reasons. One, fluid sims at really small scale aren't the best to work with, and bullet sims aren't the best to work with at very small scales. So we're going to scale up a little bit and take a little bit of liberty with that, and we will scale up the simulation or speed up the simulations timescale, play with stuff like that in order to compensate for that. You could probably have it a little smaller than this, but I think for the fracture and everything like that, this is like a fine size for stability. So we're going to work with this size. I'm just going to go ahead and delete the biped, and I'm going to switch this to hide other objects. Now I'm going to go ahead and remesh this just so we can get some better geometry. I don't think the geometry on this is the best for fracturing at the moment, so I'm going to go ahead and go to smooth wire shaded. It's not terrible, but I do want to clean it up a little bit, get a bit more control. I'm going to drop down a quad remesh, just like that. Going to visualize that, and you're going to see it gives us a very strange result. So we're going to change some settings here. So I'm going to go over to the alignment, and I'm going to go to this field and change it from face to edge. And if you give it a second, you see that it gives us a much more reasonable response. And to be honest, this is an absolutely fine remesh. For the shot that we're creating, we're never going to have a close-up of the bottle, so the fact that the lip is kind of messed up here isn't really of any consequence to us, but we are going to do our best to smooth this out anyway, just because it's good practice, and it's going to help with the cloth collision later anyway. I'm going to come over to the topology tab here, and I'm going to do, instead of resolution mode, I'm going to change this to relative scale, and I'm just going to play around with this until I get something here that's not terrible. As you can see, it's already a much better rim of the bottle, or lip, and we're still going to change this later anyway. I'm going to go see what looks the best. So we don't need this many polys, obviously. I think I'm going to go ahead and do -1. I know the lip is still messed up, but we will smooth it out shortly, so that's absolutely fine. And to smooth it out, I'm going to drop down a subdivide. And as you can see already, the subdivide has smoothed out the rim a little bit. We don't have the greatest topology here, but again, I don't want to spend too much time on this because as long as the collisions are good, we're never going to have a close-up of the rim of this bottle like this. It's going to be a wide shot. At least for me, so we don't need to worry about this topology too much. The default settings right now are absolutely fine. There are a few things you can change. You can change the algorithm, like Houdini, Catmull, Clark, and in this case, it didn't give anything. Didn't give a noticeable change, but you can go ahead and play with those. You'll get different, very different results. But in this case, I'm just going to leave it alone and open subdiv Catmull Clark. After this, I'm just going to take a few precautions. I'm going to do a poly doctor. The reason we're doing a poly doctor is that when we fracture this, if there's like holes and stuff like that in the mesh, when you go to render it, you can get very strange artifacts. Sometimes they manifest as like these big spheres in intersecting points and holes. So we're just going to polydoctor, close any holes, stuff like that. You can see we've got all of these options. What we want to do with overlapping, repair, delete, all stuff like that. Any disconnected points I want to repair, stuff like that. I think that's all good. And that should be fine for now. And then I'm going to go ahead and put down a polyfill. Just like that. And then with the polyfill, I'm just going to set this to triangle fan. I mean, any holes that were not patched by the polydoctor, we've now sorted out. And in this case, it says no patches were created because there are no unshared edges to fill, which is great. Which means there are no holes. I've made this project file a few times and tried a few different methods of creating the topology. And sometimes I have holes, sometimes I don't. In this case, I don't seem to have any holes. So I clearly don't need it. So I'm just going to delete it. And we shouldn't have any holes to worry about. Next thing we want to do is fracture the bottle so we can actually smash it. So I'm going to put down a material fracture, an RBD material fracture specifically. I'm going to go ahead and click the view flag on that. It'll take a second to initialize. We have a pretty lackluster fracture, and that's just because right now it's set to concrete. We're obviously not fracturing concrete, so let's go ahead and change that to glass. Give that a second to change. And you can see we now have one impact point, and it looks a lot more like glass. So immediately, what I'm going to want to do is have a few more impact points. The more you have, then obviously the more shards you'll have. So I'm going to say I want at least 4 scatter points so I can have more points of impact. It's really up to you completely how many you want. The more you have, the more shards you'll have, the slower the simulation will be. So take that into account with your machine as well. I'm happy with the amount. I'm going to change the seed a little bit so I can get a different arrangement of scatter of this. Yeah, and I'm a bit happy with this distribution. We've got one impact right on the neck of the bottle there, and we've got one here in the body, and we've got another one here in the body, and then one just below there. And obviously we can come back and change this if we're not happy with the way it shatters. In the cracks tab here of the material fracture, we have a lot more settings. You can see we can change the radio crack number, which will just change the way that this kind of circular radial crack works. Actually happy with the default of 20. All of these you can play with and get a different look. If we change the impact spread down, you'll see that we have very little impact spread. And if we go all the way up, you can see this this spider web of impact spreads out a lot further from the initial point. Again, I'm really happy with the initial settings we have here. So I'm going to leave that at default. Chipping, I'm going to leave off for this. All chipping does is enable those tiny little chips in between the cracks, which do add to the realism and to the simulation. In this case, I'm going to leave them off. I believe in the project file, they're off as well. They can add some annoying complications. In my opinion, they do make the simulation a little bit better because you do get those chips in real life. It makes it a lot slower as well. For now, I'm going to turn these off. We're not really even going to see the bottle smash through the explosion of flames, so we don't need that to be on, and it's just going to slow us down. So we're going to leave that off for now. So in the detail tab of the RBD material fracture, you can see we have options for the detail. So the detail size is just the variation and noise that we have on these cracks. So we increase that something crazy like 4. Well, in this case, it's actually going to smooth them out because the noise will be scaled up, so we'll see less of the effect. So actually, let's go down if we want to see more detail. A little more detail, as you can see, is actually intersecting and kind of destroying our topology here, destroying our bottle. So we're not going to do anything crazy with that. Again, please feel free to play with these settings, but right now the default is giving me something I'm really happy with. At least I think I'm happy with. We're going to have to still smash it and find out. But for now, I'm going to leave all that as is. There's nothing in the constraints tab I need to change yet. We will be coming in here probably to change the strength of the constraints so that it will smash. But for now, let's just worry about throwing the bottle at the wall and destroying it. After this, we're going to drop down an RBD connected faces node. And what that's basically going to do is understand which faces are touching so that when we render this, the bottle doesn't look pre-cracked until they're separated. So it all looks like one connected piece of glass instead of a bottle with a bunch of cracks in it. So after this, I'm going to go ahead and do an RBD.io. The reason I'm doing an RBD.io here is so that we can cache everything we've done so far, so that every time we simulate, we don't have to remesh on every frame, we don't have to refracture on every frame, which can be super slow. So what we're going to do here is untick simulation. Instead of frame range, we're going to do single frame, and we're especially going to untick time dependent cache, which means that it will cache one frame for the whole timeline. It doesn't matter which frame we're on. So that's what we're going to do. I'm going to go ahead and name this fracture cache, and that will reflect in the base name. It's always a good idea to name your file caches. And I'm going to go ahead and save the disk. And if we go ahead and put the display flag on that, you can see no matter what frame we're on, it has saved that bottle as is, including all of our constraints and our fracture and stuff like that. It does mean when we go back, we'll have to change settings, we'll have to recache, but as you saw, it only takes a second and it's only for one frame, so it's really not too much of an issue. So obviously, if you're familiar with basic laws of physics, you'll know that something at rest will not act unless a force is exerted upon it. This bottle has no forces, so let's add one. We're going to go ahead and put a point velocity down. I'm going to put a display flag on that. I'm going to go ahead and come over to the display point trails here, just this little dot with a little trail, so that we can visualize the velocity as we change it. For example, if I go here and add curl noise, now we can see that in real time. And if you don't have that on, you won't be able to see it. Before we add any fancy noises, we're just simply going to throw the bottle, and in my case, I'm going to throw it in the X direction, in the positive X, and you can see down here in your gizmo if you ever forget which way is which. So we're going to go ahead and change this initialization from compute from deformation to set to value. You can also just add to value up here, add velocity up here. There's no difference, it's the exact same thing. I just like to use set to value. You can use whatever you want. I'm going to go ahead and set the value to something like 1020, which is actually throwing it in the Z direction. It doesn't matter really which way you throw it. So as you can see, the points have got all this stored information, and as its trail, it's going to fly up and go that way. But if we press play, nothing happens because we don't have a solver yet. So we're going to adjust more of these noise settings in a second so we can get a more dynamic throw. But first, we're going to go ahead and put a solver down so we can throw it and see how it flies. And actually now I'm just remembering, I'm going to put the point velocity from the proxy geometry input, and that'll make our lives a little bit easier before we do the solver. So we're going to drop down the solver now. RBD bullet solver, like so. It still requires its geometry, so I'm going to go ahead and do that. I'm going to just move this out of the way. Only way I'm doing that is just hovering over the line and holding Alt and dragging it, and then you can kind of make your little zigzags. Just gets out of the way because the point velocity doesn't store constraints or anything like that, obviously. So we move out of the way so we can get that connected, and I want to get our constraints in as well. So I'm going to do the same thing like this, just so I can see it. You can also just move the point velocity out of the way, whatever works for you. The nodes are going to work no matter the order or how you arrange them rather. So we've got that in, and we're going to go ahead and plug the point velocity into our proxy, and we will deal with collisions shortly. So if we go to the RBD bullet solver now and we press play, we'll see that it flies off into the distance and falls into the void, which is not what we want to do. So in the RBD bullet solver, you're going to go to collisions, and in the bottom here, you'll see ground collisions. We're going to set that to ground plane, and that will just give us a global ground plane of collisions at 0. So just to the floor. And if we go and press play now, we will see it goes off into the distance, and actually surprisingly has enough force to break a little bit. But if we go over here, you'll see that the bottle is not as compromised as we like. And if you've ever seen glass break, it doesn't really break like this. So this is where we're going to have to go in and tweak the constraints. So if we go back up to the RBD material fracture here, and we go to our constraints tab, you can see that we have a lot of strength, like they're really strong. So we're going to lower these from 10k to about half and go for about 5,000, and we're going to lower this 4k to, let's just say 5,000, and see how that goes for us as well. Again, we're going to have to recache real quick. It's not going to take us long, and then we're going to go down to this and press play, and you can see way more of that smashes, but it's still not quite enough. So let's lower those even more. Let's try something like 1,000, 1,000. Go ahead, file cache, save, back into my solver, Okay, that smashed a lot better. You can see it had this kind of secondary impact where it smashes there. Obviously we're not throwing our Molotov, well, I'm not throwing the Molotov on the floor here. I want to hit it against the wall. So before I tweak this further, I'm going to go ahead and get a wall set up that we can throw this against. So I'm just going to drop down a simple box, just like this. And I'm going to put the display flag on it, and I'll put the template selection onto the solver so I can still see it. And we're going to move the box. I would like for the box to be starting from the ground up. So I'm going to do the center on 0.5. I'll just move it up half a unit so that it's sitting flush on the floor. And then from there, I'm just going to kind of eyeball it and move it how I please. You can move it obviously with the transform node or with just these. I don't think it really matters too much. So I'm going to go ahead and move it like so. Make it a little bit bigger. I'm actually going to use the size here just for a bit more uniform scaling, just so I can get it a bit wider and a bit taller. There we go. We've got a nice little wall there. And in order to get the collisions, it's really simple. All we're going to do is plug this straight into the collisions geometry like that. I'm going to go ahead and take the template off, move the display flag back, and we will press play. So you can see the ball flies just straight into the wall and shatters, which is what we want. One of the things I'm going to do as well is give the bottle some more noise. I don't think you've ever seen someone throw anything that's in this kind of way. There's no twisting or anything like that. I will also move the wall slightly further away so we have a tiny bit more time in the air. There we go. And I might move the bottle up a little bit. So let's say maybe like 15 on the Y. So it goes up. A bit too high. Let's hit it with like a 12 and see. Okay, that's perfect. So another thing I'm going to do quickly while we're here is I'm going to drop down a null just underneath this box. And I'm going to go ahead and call it out wall. Just because I think we're going to be referencing this a bit later for some other collisions. I'll name the box wall as well. Doesn't really matter, but it's good to have your points, your nodes named, sorry. So I'm going to come down to the RBD bullet solver, the point velocity, and let's get some more interesting noise on this thing. So again, I'm going to turn point trails on. I'm going to come to curl noise. Or maybe, yeah, I'll start with curl noise. And we will I'll scale it up a little bit to like 4. And we'll just see how it flies. Again, I'm going to turn this off quickly for visualization. We can see we're getting some twist now. It's not strong enough. The reason as well, you might have noticed that the simulation is so slow now is because curl noise is actually really heavy when it's animated. So if you want to speed up, turn the animation off and you should see some speed come back. There we go. So that's okay. It's twisting a little bit. I'm going to scale up even more, something crazy to 10. Still doesn't fly as fast as I want. I'm actually going to change the entire time scale as well. You have to realize this bottle is really big. It's like the size of a person. So we need to scale it up so that it flies as fast as a bottle will instead of a person. So I'm just going to do it by, to set it to 2. So it's twice as fast. And I'm going to press play. Okay. That's a little bit better. I might increase the sub steps a little bit. But for now, I'll leave that. Go ahead and tweak some more stuff in the point velocity. Just turn back on this to see what we can play with the swirl size at all and get some gnarlier twists. Okay, that was definitely a gnarlier twist. But you get the idea. Play around in the point velocity. You can add conical noise as well. I don't think you really need to, but feel free to if you want to try stuff out. Get some interesting twists and tumbles and stuff like that in the air. And one kind of just throw it straight down on the floor. So I don't want to do that. I just wanted to hit high up. Okay, I have tweaked it a little bit. I changed the wire force to 15, so it goes a little bit higher. And then I changed the curl noise to 7 and the swirl size to 1.2, so that it Still manages to go up, but it still flips over itself at least once. So we get this nice dunk. But again, play around with these settings, you can get some very interesting dynamics. So in my case, I don't want the bottle to go immediately on frame 1, because that means we won't get any time to see the cloth burning or to understand the setup. It'll just go immediately. So what I want to do is make sure that this velocity is only injected after a certain frame. So we get like a second or so to see the bottle and the cloth on fire before it yeets itself with the wall. So that's what we're going to set up here. It's going to use a couple attribute wrangles, but it's real simple. So don't be afraid of the like 2 lines of code that we're going to write. So after this velocity, we're going to do an attribute wrangle. Okay. We drop that down in between the point velocity and the RBD solver, bullet solver. We're going to go in here. It's running over points, which is fine. And we're going to type I at active equals 0 semicolon. And I at animated equals 0 semicolon. What we're basically telling Houdini here is that we don't want this object to be active at all. We want it to just be completely stationary. We don't want any of the information on any of the points to act on it yet. We just want it to be not active and not animated. So it won't interact with anything and it won't move. And then we're going to drop down another attribute wrangle directly after that. You could just alt drag to get another one. And I just shook it to disconnect it. And then we're going to plug it directly underneath the last one. And what we're going to do is we're going to do a little bit of an if statement. We're going to do if, open parentheses, at frame, is greater than or equal to 25. I'm going to do a little tab just so I can see what I'm doing here. So new line, tab, you don't have to do the tab. Then I at active equals to 1 semicolon and I at animated equals to 1 semicolon. So we're basically just saying after frame 25, which at 25 frames per second is, you guessed it, a second, then everything will resume as normal. I haven't checked for typos, but we're going to go ahead and press play and see if that works. Save and then just press play. And there you go. You can see after frame 25, the bottle launches and we're all good to go. There are other ways to do this, I'm sure, but this is just the simplest way I've found to easily control exactly which frame we wanted to launch on while storing the data from the velocity data from the point velocity to inject it exactly the frame we want. Because funnily enough, you actually cannot keyframe the point velocity to activate on a frame later than 1. Point velocity, at least to my knowledge, can only be activated on frame 1 without some kind of wrangle or solver or something like that. You can't keyframe it directly. So this is the workaround that we use for that. So now we have it so that after 25 frames, the ball will throw itself at the wall, smash, and crumble to the ground, which is great, except that it probably isn't. If you've ever done an RBD sim, you'll know that if you have smallish pieces like this, when they're on the ground, they refuse to settle down. So if I go ahead and press play on this, you'll see that they just keep on rumbling and keep on rolling, especially the smaller pieces in the back doing some sick breakdancing. So this will go on forever. They will never settle down. They will keep on partying, which is we don't want that at all. So I'm gonna show you one way that you can do this. It's a pretty limited kind of brute force way, but in a case like this where you want things to just settle down in a pretty controlled way, this is the way I would do it. You can set up a gradient from the floor upwards, so that the closer stuff gets to the floor, the slower it is, like its movement is damped, its angular velocity is damped. But the problem with that is if you have something launched from the floor here, like this bottle, it will be affected by this kind of gravity field. So it's only really applicable for stuff that's falling down from above, unless you want to keyframe the amplitude or the gradient or the ramp, which I'm sure is not hard, but I just want to go with a simple solution for this. So I'm going to show you how to do that. So what I'm going to do is I'm going to actually go inside this RBD bullet solver, and above the pre-solve, this first one here, I'm going to go ahead and drop down, first of all, merge, because we're going to be merging 2 drags in here. I'm going to do, the first one is a pop drag, so normal pop drag, merge that in, and then a pop drag spin for the angular velocity as well. And we're basically gonna manually keyframe the amplitude of these, or the strength of them, so that we can make the pieces settle down. So we're gonna need to find out where the pieces hit the floor, and then when we want them to settle down. We've put the pop drags on, which is why the bottle barely makes it to the wall. So let me just disconnect those, and then we'll press play again. So let's play. The ball flies out, smashes to the ground. And then we probably want them to start settling from like when the last piece hits the floor. So like from here, there's a couple pieces coming down. So maybe from like here, 65, frame 65, and maybe we'll give them 5 to 10 frames to come down, maybe like 10, 15. So we'll do 65 to 75. So we'll go back into the RBD bullet solver. We'll plug these back in, and we'll say, instead of changing the resistance, we'll just change the activation. So we'll go to frame 65, or 64. Oops, that's the wrong place to plug it in. Here, go to frame 65, and I'll have the activation off. I'll do the simple bullet for these. So I'm just going to alt click in there to keyframe, and then we'll go to 75, and then I'll put the activation on 1, so it's fully activated, like that. And we will go out and see if that has worked, if it settles them down or not. So there we go, smashes, and then now it started to settle down. And as you can see, the pieces, you know, they're a little wobbly, but they do settle down. And most importantly, they're not spinning around infinitely in the background. Obviously, I can't tell because of the slowed playback if it's working perfectly. So what we're going to do is I'm just going to do a really quick flipbook. If I can find my flipbook window, it went to the other side of the monitor. And we're just going to be able to play it back here in, you know, normal full speed once it settles down. And I'll press play. And you can see, yep, everything settles down reasonably, just like that. Nothing is spinning around. And that's just a really easy, simple way for this kind of thing. You just keyframe it. It's not super procedural. There's no, you know, I'm not using a wrangle or if this is like near this. We're just doing something real simple. Because this is a real simple fix in this case. So after you're happy with your simulation, you've tweaked all your settings, you've got your point velocity, everything is all tweaked and good. We're going to cache it out. So I'm going to drop down a RBD IO again. And in this case, we really actually don't need an RBD IO because we don't need the constrained data. We don't need the proxy. So you can just drop down a file cache here, which, you know what, actually, we'll just do that. Make it a lot simpler for ourselves. We'll just drop down a file cache and make sure you name your file caches, please. I'm going to name this bottle smash sim because that's what it is. It's the simulation of the bottle smashing. It's a simulation. I want the whole frame range, and I'm happy for it to make the base name up from the node name. You can also just do explicit as well if you want to name it exactly. But in this case, I'm happy with the file structure that Houdini wants to create for me. So I'm going to go ahead and press save the disk. And now we have that saved out. We go ahead and press play. You can see we have everything smashing. Now we can see like this, you can see they do settle down a little fast. Maybe I should give them 15 or 20 frames. At this point, everything will be on fire there and you won't really be able to see the glass. So I'm going to leave it just for the sake of tutorial, but feel free to tweak it to perfection on your own file, if you so please. And after this, we're just going to drop down on RBD disconnected faces, not connected faces like we dropped down earlier. And this is basically just going to detect, whoopsies, it's basically just going to detect when these connected faces have broken apart, because they're not staying together. And after that, I'm going to drop down a null. I like to make my nodes black, just so they're really easy to spot in a node network. Don't worry about those errors. I was just cancelling a cook earlier. But I like to have my nodes be black so that I can quickly see where they're going out to. You know, you can have them red, whatever's easier for you. And I'm going to go ahead and name this null out bottle smash. The reason I always put out in all caps before my nulls is that when you reference these things later, so if I do a object merge, for example, just an example, and I go to here, you'll see at the very top, anything with all capitals first will show up on top, even of things that are higher up in the alphabet. So you see we've got attribute wrangle, which is an A, and we've got out, which is an O. The out will show up, first, because it's in caps. So it's an easy way to get to your nulls without having to search through a bunch of things. So it will save you a lot of time. So we're actually basically done with the bottle smash now. I don't like the way Houdini just organize them there. That's basically all there is to the bottle smash. It's very simple. It's not complicated at all. And you can tweak it as much as you like. You can throw it, a more complicated object than a wall. You could throw it at like a car mesh or something animated or, whatever you want. But the principles will stay the same. So after this, we're going to just go ahead and go back up to OBJ level and move on to the next piece of the puzzle. So I'm going to drop down another geometry container. I'm going to name this cloth because that's what we're going to tackle next, is the little cloth that hangs out of the Molotov. So there's a few ways we can go about this. I actually have, if I drop down the file, a cloth prepared. Let me put down a normal so you can see it. This has like the folds in it, so you get like that fold kind of thing. I'm not going to use this for this tutorial, but you are more than welcome to use it, just because I'm not super keen on the geometry of it, and you can remesh it, but I'm going to stick with something real simple for this tutorial. You can use any cloth mesh you want, as long as it fits inside the bottle, and I'll show you how to attach it and simulate it. But in this case, I'm not going to be using it. It is going to be in the project file, so feel free to use it or don't. So what we're actually going to use is a planar patch. I'm going to planar patch, and I'm actually going to ghost other objects so I can see the bottle, because we're going to line it up and put it inside of the bottle basically. So I'm going to go ahead and drop down the transform node after this so we can move it non-destructively. I'm going to just yoink it up on the Y, and I really want to make this longer because it's a square. So I'm going to change the shape to a trapezoid. And the reason I'm making it a trapezoid is so that we can skew it. So if I make it skewed to the bottom, or tapered to the bottom, then you can see we can get like the bottom in while flaring out the end. But we're going to make it a little bit longer first. So I'm going to change the size in the planar patch and on the transform first, just to make it a little bit longer. I'll keep the transform on though, just so I can see it. And then I'm going to make it tapered, just a little bit tapered, just like this. Maybe even like 1.5, something like that. And maybe like 1.4, 1.5. Not super important. And we'll make this a little bit thinner too, like 0.5. I might make it just a tad longer. No, 1.5 is fine. And on the transform, I'm just going to move it up. Again, you can do it in the translate if you want, or you can go ahead and just come down here and click the show handles. I'm a Blender user by trade. That's what I started with. So using the show handles is a bit more in my nature, but I know there's a lot of Houdini artists who only move things by very precise increments. So it's completely up to you. One of the other things we're going to do as well as bringing it up in the bowl is rotate it so that when the bowl flings, that when we simulate the cloth, that it doesn't fall straight down and that it actually rests on the back of the bottle. And I'm believing my bottle is going that way. I'm just going to double check. It is going that way. So I want to rotate this slightly so that it will fall down over the rim. And of course, I will just move it back like so. So it falls down like that. And that should be good. I might make it just a tiny bit thinner. That was more than a tiny bit. 4 or 5. That's okay. 0.4. And one of the things I'll also do is decrease the edge length, just so that we can get more detail on there, so that it's not so stiff, so it can bend down, so the cloth can bend. It has more places to bend, because obviously if you have the rest length like 1, it's going to be able to fold across these 3 lines. So I'm going to hit something like 0.05, maybe 0.03. We'll start with 0.05 and we can always adjust it later. After that, we're basically done with making our cloth for now. Well, I'm sure we'll revisit it if it's not in the correct place. So now we've got our cloth set up, basically just these two little nodes. We are going to set up a simulation. So the first thing we're going to do is drop down a cloth, vellum configure cloth. What this node is essentially doing is giving us all the settings we need for our material. So how stretchy it is, how bendy it is, stuff like that. So that's what this is going to do. We're not going to configure any of it now. We'll come back to it. And then we are going to do a vellum solver, just so we can see our stuff in action. Just like this. Put the display marker on it and we press play. It falls through the bottle, which is exactly what we would expect. There's a few problems to solve here. One, it falls through the bottle before we have it get to a good rest point, meaning that the simulation will start like this, which is not what we want. And then before it will settle, the bottle is going to go on its merry way, which, again, we don't want. So what we're going to do is we are going to solve the first issue, which is the bottle going off on its own. But we need some colliders because it's falling through the floor. So the first one we can do is very easy. If we go to solver and collisions, we will see, again, ground position, which will give us a basic floor for it to collide with. And then we need to bring in our wall. So I'm going to do an object merge, and you guessed it, I'm going to go ahead and merge that out wall from earlier, and I'm just going to go ahead and I'm going to plug that into the collision geometry of the vellum cloth, and that will carry down the collider through all of the vellum nodes, so you don't need to worry about plugging it straight into the solver. So I'm going to go ahead and press play, and we still don't have collision for the bottle. So what we'll do is we'll add a merge. We'll do another object merge. So a lot of merges here. I did Shift R to change them there. You don't need to, it's just I don't like the way they're tangled. And I'm going to go ahead and grab the bottle. So we're going to do out bottle smash. Let's go ahead and grab that. One of the things I'm going to do here is, now we have the bottle in, I don't need to really see the other one. So I'm going to do hide other objects. So we only need to see what's in here. And now all this blue stuff, all these blue outlines are just our collision geometry. So if we press play now, you'll see it falls on the bottle, and then the bottle, when it initiates in just 1 second, you'll see that it's going to fling this bottle, and it's going to fling that bottle and really stretch our cloth. In this case, it's pretty lucky that the cloth doesn't slip out of the bottle immediately. But we're going to pin it to the bottle anyway, just to make sure that it does not fall out onto the floor before it hits the wall, because that wouldn't be that wouldn't be ideal. So let's sort that out. I'm going to add a time shift. There's a lot of time control nodes in this program, and I'm going to just have it by frame 1. I don't want it to change frames. I'm just going to do Control Shift click to remove the expression, and just have it on frame 1. What we basically said now is we want to keep this on frame 1 forever. So we're going to leave that on for now so that we can have the collider settle properly. So we press play. We'll see that it indeed does just slip out of the bottle, because it's not pinned, and it falls kind of pitifully to the floor. So we're going to fix this. The first thing we're going to do before we even do any of our cloth settings is we're going to add some attaches. So we're going to attach the cloth to the bottle. So I'm going to go ahead and drop down a vellum attach to geometry and not constraints. I'm going to drop that in the middle of these, and we have an attach. So you can see immediately it's trying to attach every point on the cloth to any available point on the bottle, which will look pretty crazy. If I press play, it should just it will stay on the bottle, but it won't flap freely, because if I go ahead and click on the attach again, you can see that all of these points are grabbing here, so they're not going to flap freely in the wind when we let the bottle fly. And if you're curious to what that looks like, I can show you. Disable the retime. Press play. And we can see we get actually not too terrible. The interactions are not. Oops, if I could. There we go. Thank you, Houdini. The interactions are actually not too terrible at all. So you could probably keep it on if yours works out as smoothly as that. However, in the case that doesn't, I will still show you how to attach it more precisely if it doesn't just happen to work out like this, because when I was making this project file initially, it did not work out like this. So I'm going to show you how to attach this more accurately. So in the development attach, the first thing I'm going to do is change the groups to points. And what it's looking for here is it wants you to choose points from your cloth to attach. So let's see, we probably want some points that are inside the bottle. Let's say like these outside points. So I'm going to go ahead and click the select. I'll click this point. And for now, I'm going to do 1 point. You can select multiple points like such. And in this case, it's trying to attach to the nearest geometry. So it's working here, no problem. But when this shatters, I don't want it to try and snatch to another point. So I'm going to be very specific with it. So I'm going to turn off constraint to closest point. And you can see now it's just grabbing some random point, which is no problem. I'm going to delete one of these. So we have 1 point to control. And I'm going to go ahead and change this to points as well. And then I'm going to press the point select. And I'm going to choose something nearby-ish. So like 1 there. And now you can see I've told it this point belongs to this point. There's no variation in that. It won't change when the bottle smashes. It doesn't care what the next nearest point is. That is where it's gonna attach to. I don't know if this is the point I actually want. I might want one close to the back of the bottle, but for now, you get the point. That's where we're gonna leave it. And we are gonna go ahead and press play. Let me put the retime back on so that it freezes it. If we press play, it should stay in the bottle. And it is staying in the bottle just very loosely. And there's a really easy fix for this. In the development attach, there is a rest length. And this is exactly what it sounds like. This is how close they are, the 2 points you've determined at rest. So I'm going to do like 0.1. So they're very close at rest. And we'll see it snap to it when we press play. So now that point is strictly on that point. I said, hey, stick to that point. And it's listening. So now I'm going to do another development attach. You can do it in one development attach, but because we're only going to be using, or I'm only going to be using 2 points to connect this, I'd rather just have the direct control over each one. And you can also do this by grouping as well. So you can select a point of groups on the bottle and then tell the development attach, hey, I want these points to target this group, and then you can have like a group. But again, for this tutorial, it's just needlessly complicated, and I just wanted to show you guys the principles of it, and then you can expand and experiment on your own. So doing another development attach, I'll just duplicate this one and drop it further down, and I'll change the points. So instead of that point over there, I'll choose, I guess this one. This one looks fine to me. Press enter, and then I want it to attach to a different point on the bottle. So let's say like this one. And I don't want it to constrain to closest point. And if we go ahead and press play, we can see that those 2 points have snatched it. And now it is sitting nicely on the bottle. It's not slipping out. I might loosen the rest scale a little bit, just because we can see that it's like jittering, stretching across. Alternately, we can choose some better points here. So for this first one, I'm going to go ahead and change this to one like, let's try one like back here. And then for this attach, let's try one that is back here. And let's go ahead and see how that looks. Yeah, we're still getting a little bit of that jittering. We'll be able to do smooth that out with some time steps, substeps. So let's try that. And also we might be able to loosen the rest scale. So we'll just add one substep for now. Yeah, that's a little bit better. I will loosen the iron grip that I have on these points to, let's say like 0.2, and press play. A little bouncy. Yeah, that's okay. Again, we're not going to be super close up anyway, so we just don't want it wigging out. But that is how you would get, you know, that to lay in such a way. You can play with the constraints, stuff like that. I don't want my cloth to be super stretchy. So I'm actually going to go into the vellum cloth finally, and I'm going to go ahead and change the stretch stiffness to like 5. I really don't want it to stretch too much. And we'll be able to see how much it's stretching when we fling the bottle, which we're going to do now. One more thing I would mention for these vellum attaches is to make sure to enable braking, because if you don't enable braking, it can get tangled up in the glass and you can get some really weird stretching, because it's going to stay attached to this no matter what. So I'd rather just enable braking. The default settings are good. You don't need to worry about that. In this case, they're good. It will, as soon as it stretches, it will just snap off. So we're going to leave that as is. I'm going to turn the time shift off just to test some stuff. And we're going to go and have a look and see how it flies. Oh, so you can see right there, as soon as it snapped down, the braking threshold actually snapped it off when it fell down like this. So let's change the threshold to be a little bit higher, 0.5 perhaps. 0.5. There we go. So now it's a little bit higher. It won't snap immediately, and we'll just see how that goes. We can't see the bottle currently for some reason. I'll just put down the template. There we go. I think that updated it. I don't know. It kind of got confused there. So we'll play that again. And we can see that it flies with the bottle, soars like an eagle. Let me move the camera over just a little bit for you. Hits the wall, smashes, falls down, and that is where he rests, which is exactly what we wanted. Let's play that again, just a little speedier. Just like that, perfect. Flies, smash. You can, again, if you increase the substeps, you'll get less of this crazy stretch, which we will do. And also we're going to increase the stretch stiffness in the cloth so that, again, we get less stiff. So I'm going to put that all the way up to 10. And then I will also add, you can add as many substeps as you want. For the sake of speed right now, I'm not going to add too many because there's still one more thing we need to do. And you might have noticed that this big old wedge is still sticking up on frame 1, which defeats the purpose of the animation really starting on frame 25. So we're going to have to do some time travel. So what we're essentially going to do is we are going to, I'll turn this retime on. We're going to simulate up until a point where we're happy, where it's resting. Okay. And then we will cache that out and then re-import that back in as our actual new source. So the simulation starts from here. It's a little cheeky, but it's a really easy way to get it to start at this rest pose. So I'm going to go ahead and do exactly what I just said. I'll increase the substeps a little bit, maybe to 4. And then I'll let this play out. Oops. Increasing the substeps. Decided to kill the vellum attach. I'm going to turn the braking off just for now. And I'll tweak that after. There we go. I'll let it settle down like a little bit. And you know what? Yeah, that's probably good enough right there. I am going to then go to the vellum solver down below, and I'm going to do a file cache. The reason we're not doing a vellum IO, because there is a vellum IO, just like there's an RBD IO, is because if we store the constraints from this, it will actually save the pins. And this took me a whole night to figure out. It will save the pins, so these vellum attaches. So when you re-import your cloth to plug back in, it will never move because it's pinned to this imaginary bottle. So use a file cache, file cache. Use a file cache and save yourself the 3 hours late at night that I spent trying to figure out a very simple fix. So we're going to go ahead and name our file cache cloth initial state, because that's exactly what it's going to be. And you already know the drill. we want it to be not time dependent at all, just a single frame, which is exactly what we're going to get. So just save the disk. We go ahead and check that. We see we've got a perfectly still little cloth. So with this, I'm going to go back up to the top here, and I'm going to do a object merge. So I'll drop down a null. I like to make it black. I'll do out cloth. I'll do out cloth initial. If I could spell, it would help. Initial state. A bit of a long one. I normally prefer short file names, but it's fine. And then this object merge, we will find cloth initial state, and we will plug that in instead to our vellum cloth instead of our planar patch. So I'm going to say cloth initial state here as well. Plug that in there. And then we go back to the solver. Now we start from here. We press play. Because the points are the exact same on these two things, you don't need to redo the vellum attaches. They'll work exactly on the same points. So you see it just starts from there, which is perfect. Exactly what we wanted. So now we can unfreeze this. I'm going to go ahead and save. Make sure to save your project. And I'll press play, and we'll see how that reacts. There's a lot of time steps, sub-steps on right now. I'm going to just lower those for the sake of speed for the tutorial. And we'll see. There he goes, flying off to the distance, staying attached to the bottle, and he will smash on the wall. You've seen it before, so I'm not going to play the whole thing again, because we do need to catch this. I will increase the sub-steps back to 4 or 3. It looks pretty decent. And then we are good to cache this out. So for this one, I'm actually going to do a vellum IO, just because we're going to do a vellum post process after, and it can use all this information. So go ahead and name that. So I'm going to name this cloth sim, because that's simply what it is. Nothing crazy we need to do here. It's a simulation, our frame range. Save to this. While this is simulating, I just want to say thank you guys for your support. You know that the project files are free, and they will stay free. I just ask that if you find them useful or find the videos useful, you subscribe, and maybe check out the merch at dammydigital.com/merch. Buy yourself a t-shirt, buy yourself a cap. It's the season for it. It really supports the channel, and I would appreciate it greatly. Back to the video. So now we have our cloth sim cached out like so. Flings itself out and falls to the ground. Gets yoinked to the ground. It kind of looks possessed when there's no bottle with it. So I'm going to go ahead and put the template on the bottle so I can see that as well. And there you go. It's in context now, and it looks a little bit less crazy. I'm going to tweak some braking on this just because it's getting yanked down by the smashed bar. So I'm just going to go ahead and do that really quick. Okay, we are back. All I changed was a couple of settings. So I changed the timescale to 2. So we have the cloth a bit faster to match everything else, because when I changed the braking, the cloth was fluttering down too slowly. So I changed it to 2 so it falls down quicker, like a wet rag would, because it's soaked in, gasoline or lighter fluid or whatever. So I press play without this, so you can see. You'll see that now it flings and falls down on its own. It doesn't get yanked down by the thing, by the glass, because I changed the braking settings on the vellum attach. So I changed the threshold back to 0.1 for all of them. I just changed the type to stretch distance instead of stretch stress, because what was happening was that when the rest scale was yanking the points closer, that counted as stretch stress, so it was breaking them immediately. So I just changed it to stretch distance. So now when it gets to a certain point, if we can find that point, somewhere around here, it gets distanced from the shard. I think right here. Yeah, right here breaks off from the glass it was attached to. It gets too far away, so now it's its own free agent, and it can fall to the ground. Again, you won't see too much of that in the explosion of gasoline, but it's good practice, and it teaches you how to do this kind of attach without it getting tied up in all the glass and everything. So after this cloth sim, again, we're not going to be too close to it, but it's a good habit. I want to drop down a vellum post process. Does exactly what it says. We get to tidy up our cloth. Let me just untemplate the bottle. And you get to do all kinds of good stuff to this in post. So I'm going to hit the subdivision so we can get some more detail. You can make it as detailed as you want. You can change the type of subdivision. And you can detangle it. Again, ours isn't really tangled. Oh, there's a little tangle there, which will stop it colliding with stuff it shouldn't do. So I'll detangle as well. And then this is where you add your thickness as well. Whoopsie doodles, that is a thick cloth. So you just add it in post instead of doing it in the simulation, which would have added a lot more polygons to calculate. You just do it after in the Vellum post process, and it's basically the exact same speed. I'm gonna unsubdivide it by 1 because we're not that close. We don't need to see that much detail. But if you are gonna be close, go ahead. But we're basically done with the cloth now, so we're gonna drop down a null. I'm gonna make it black, and I'm gonna do out, and you guessed it, cloth. And I'm gonna go ahead and save. So we're getting there now. We're about halfway with the amount of things we need to do. All we need left is the liquid and the pyro. So we're going to go ahead with the liquid. So I'm going to drop down a geometry container and I'm going to name it liquid. Jump in there. And we are going to start with the fluid that we're going to set on fire. So the first thing we're going to drop down here is a tube. And I'm going to make sure it has end caps. That's important. It doesn't really matter how many columns it has. It's not super important. As long as it can have a rough shape of the bottle. And we're going to go to up here and change it to ghost other objects because it's actually important that we see the bottle for this point. And what we're going to do is basically put this tube inside of the bottle at the moment it smashes, and that is where we'll source our fluid from. You, of course, through many sub-steps and great pain, put the fluid in the bottle and then throw it and have it splash. But you have a lot less control over the splash itself. And it's a huge headache to contain the water or gasoline or lighter fluid or whatever is in there inside of the bottle. So we're going to cheat it in this tutorial just to save ourselves a massive headache. So I'm going to go to the point where the ball smashes on the wall, the frame, just the frame before. So 31, it's not smashed. 32, it's not smashed. 32, 33, it's smashed. So 32, the frame before it smashes, we are going to put this tube inside of roughly, it doesn't matter too much really, inside of the bottle. So I'm going to go ahead and drop down a transform, and I'm going to move this bad boy over there. There are set views. You don't need to do it roughly. You can use the top viewport and rotate it exactly as you want there. But again, it's rough. It's going to be visible for like, it's really not going to be visible at all. And I'm certain there are other ways you can do this. Like you can probably attach a tube to like the bottle and stop at this frame and extract the tube. I don't know how to do that. And if you do, I would love your input in the comments below. One of the things I like about these videos is that I get to learn a lot of ways to optimize my workflow through the tutorials. So, you know, I don't know everything and I'm always open to learn more. But until then, we're going to just put this inside. This is probably off by like a mile or two. But again, it really doesn't need to be super accurate. Obviously going to change the radius scale a little bit on the tube. And then we're going to get that. There we go. Just about it. Again, it does not need to be perfect. We just need to source the splash roughly from where the bottle is. So I'm going to go ahead and move this way, shift it that way, a little shimmy here, a little shimmy there, rotation there. 2 steps to the right. Take it back now, y'all. And that is good. I'm going to make the radius scale a tiny bit bigger there. You can spend all day doing this. I just said it's not that important and I'm tweaking it way more. So I'm going to do this. That's fine. That's absolutely fine. And what we're going to do here, this is going to be our source of fluid. So on the frame that this bottle smashes, which will be the next one, this fluid will splash everywhere and then we'll get it to stick to stuff and it will set on fire and it'll be great. So what we're going to do is I'm going to turn hide from of objects on because we don't need to see the bottle anymore. And I'm going to come down below this and drop down a points from volume. I'm going to go ahead and set the point configuration to tetrahedral because I think it packs them just a little bit nicer. And the point separation, we're probably going to match to the fluid, but seeing as we haven't done the fluid simulation yet, we'll just set it something like 0.05 for now. We can come back and tweak it later. It's no problem. I'm not going to change any other settings. And then I'm going to add our favorite, a point velocity. And this is what is going to source our splash. This is what's going to create the big old splash. So we go to display point trails, and we go to curl noise. This is what we're going to be doing. We're going to be putting noise on these points. And when we have it as a fluid, when we source these points as a source for our fluid, they will inherit this velocity and splash out. For now, I'm going to leave everything as default because we can't see the splash yet, so there's no point tweaking these values. So I'm going to drop down a null. I almost typed out. That's how you start typing out. I am on the null. And I'm going to go ahead and do out splash setup. Just in case we need this later. And we're going to drop down a DOP network. And this is exactly where we're going to create our fluid simulation. I'm going to name this Splash Sim. And next to this brain, here you have the DOPS network selector. So you can, which is just dynamic operations. So any simulation and stuff like that. So you can choose which one it's going to use if you use one of the shelf tools, which we are going to do. So we are going to select particle fluids and then flip fluid from object. And then we're going to go into the liquid. So make sure you have your display flag on the null or the point velocity. And then when it asks you, it'll take you to OBJ level. And then you can select the fluid, the liquid one, which should be some points. And then just press enter. And then it should take you inside your splash sim and set everything up for you. Saves us having to put down 4 nodes. I know, big time saver, but you take what you can get in Houdini. But as you can see, we have nothing in here, in this sim. It's just a big box. We press play, nothing happens. There's a few reasons for that. We need to change the input type to particle field because we already have a particle field we're going to import. And we need to change the swap path to be a bit more specific. So I'm going to enter that and then choose our out splash setup. And then you can see now we have some stuff being sourced. I'm going to turn off point trails. We've got a big old box here, which we don't need all of this. So I'm going to change in the flip solver volume limits under volume motion. I'm going to change the box size something a bit more reasonable. Maybe this for now. I don't remember how big our scene is exactly, but we will tweak it as we need. And I'm going to go ahead and press play. And you can see it inherits the velocity we put on it from the point velocity beforehand, and it splashes out our points, which is neat. It's really awesome. There's no gravity here, so it's kind of just splashing out in this cool space abstract way. So let's drop down the gravity force, and then let's drop that in just after the merge, and now you can see it drops to the ground with with gravity. We don't have this nebulous fluid floating through space. Another thing we can do here is make sure our particle separation in the simulation is tied to the one outside of it. So I'm going to go ahead and right click particle separation and click copy parameter. And I'm going to come back out and go to our point velocity, our points from volume, and I'm going to go paste relative reference so that whatever we change the particle separation to here, so let's do 0.02, go out, we'll see that this is now changed to 0.02. So it'll save us having to come out here and change this every single time that we want to change it in here, which is annoying, but we don't want to do that. So I'm going to put it back to 0.04 for now, just for speed, and we are going to play with a few things. One, the time scale, I'm going to change slightly, like probably 2. If I just press 2 and press play, that's a little bit better. And I'm probably going to leave this on splashy, just because, you know, we're making a big splash. That's the whole point. So I'm going to come back out and go to our point velocity, put on display point trails, and we're going to make this just a little bit crazier. One of the things I want to do is have it fly into the wall as well. We don't want it to just splash and not go in the direction of the wall, because we want to pretend that it's inheriting the velocity of the bottle, when obviously it's just coming into existence one frame before the bottle smashes. So our bottle's going on the positive on the z-axis, so it'll be going that way. So we're going to want to add some velocity, and of course I'm going to go do it in the set value. Again, you can do it in your add velocity, and I'm going to do it on the z, so x, y, z. I'm going to add, say 5, and now you can see it's got a little bit of velocity going that way. And I'm going to increase the scale of my curl noise to like something like 5. And the only way you can really see the effects of that is hopping back into the simulation and seeing. And we are going to add our colliders in here as well, because we have no floor and we have no wall. So let's do that as well. So I'm going to drop down to static objects, and that's going to be our collider. And I'm going to go ahead and into the static object, and the swap path, I'm going to go ahead and find where I put the wall, which will be in the bottle smash, and it'll be out wall right there. And now I can see how much space we need with the bounds. I don't need anything behind the wall at all. And I don't need anything below the floor either. It's just not too much. I don't need anything this high either. But I might splash fairly high. So I'll leave it like that for now. And now we should have collisions on the wall. If I just zoom in here and press play, turn off my trails, we can see that it splashes against the wall and kind of curls out. Right now it's not sticking to the wall or anything like that, which we will of course fix, but that's the splash that we've created right now with the bottle. So I'm going to tweak it a little bit. I think I want my splash to be slightly different, so I'm going to go ahead and come back out here and tweak that. Go to my point velocity, and maybe get my swirl size, something like this, and then increase the scale, and then hop back into my splash sim, and see how that works. Okay, it's definitely a more interesting splash, and we get a bit more splash away from the wall. I don't think I want as much that far out. I just realized we didn't give ourselves a floor, so let's go ahead and add a ground plane and add that into the merge. And I'm going to go ahead and press play. Yeah, I'm not too sure I like how far back it's coming out here. Again, the splash is completely up to you. There's not really a right or wrong way. If you want your splash to go a certain way, then, you know, make it go that way. It's just a matter of what you want, really. So I'm going to come back to the point velocity. I'm going to tweak this a bit more. Okay, so I've tweaked some settings and I'm happy with that, how it came out. This is what I did on my point velocity. I did a scale of 5, a swirl size of 0.47, and left it on animated. Of course, you don't need it on animated for speed. So that is the splash I was happy with. And there's a couple of things we're going to do in here before we upscale this and save it out. So one of the things I want to do is go to the flip solver here, and I'm going to change the viscosity, and I want to enable viscosity and enable viscosity by attribute as well. And then after that, I'm going to go back to the flip fluid object, and I'm going to go ahead and click add viscosity attribute to that. Otherwise it's not going to work. I'm going to press play. We'll see now we get some icky fluid that is splashing on this, but I don't want that much viscosity. I just want it to stick a little bit. So I'm going to go back here to my volume motion viscosity, and let's half it and try that again. That's a little bit better. Now we've got viscosity. It does change my point velocity a little bit, so let's get that to like 7 and see if I can get something more dramatic. There we go. That's not too bad. So what I'm going to do is I'm also going to turn the ID on so that we can retime the points after the simulation and get some sub steps in there so that we can have some smoother emission for our pyro. I'm actually going to change the viscosity a little bit because I would like some of the fluid to run on the wall a little bit. There we go. That's a bit more like what I was looking for. And then the flip over, I'm going to go to the particle motion. I'm going to add an ID attribute so that we can get that retime and that substeps afterwards. Now I'm fairly happy with the motion it's going to take. We need to add the collision of our bottle as well, because it needs to hit the bottle too. So we're going to add another static object. We're going to name this one wall, so we know which one is which, and plug that in. And we are going to grab the wall. So out wall, name this, oh sorry, not wall, I had a brain fart. We need to grab the out bottle smash and then name this bottle smash. And we should see that. Obviously this is all not going to happen on frame 1, which is fine. We'll have this happen on frame, I believe, 34. We need to see which frame this bottle hits the wall. So I'm just going to go put that display flag on the bottle smash, which is not moving. We can see that this is not moving because it is not using deforming geometry. So we go ahead and tick use deforming geometry. Now the bottle will be animated. So I can see on frame 32 is where we want this to start. So we're going to go ahead and start it on frame 32, which we can do just out here in simulation, and start frame 32. So it will start there. We'll go back to output so we can see everything, and we'll press play, and we'll see, oops, we back up a little bit, we might see some more. We'll see that it explodes on the correct frame, along with everything else, and we are going to add some more fluid here so we can have more of a splash. Fluid objects, and let's make this like 0.015, which is a fair amount. If we go to frame 32 and turn off display geometry for the bottle, you'll be able to see a bit better what you're doing. I'm going to turn that back on for now. So there we go. We can see we've got way more fluid. You can reseed here if you want to get more fluid out. It can mess with the ID attribute, so I'm actually going to leave it on off, sorry, for now, and we'll just add more fluid and cache it out that way, and we'll see what our simulation looks like after that instead. When you use the shelf tools to create a flip fluid network like this, it will give you these liquid fluid and liquid fluid interior, and if you've ever made one before, you'll be familiar with the liquid fluid. It's a way to cache it. We're actually not going to use these for this situation just because it messes up the structure that I want to create, and we're going to mesh it a slightly different way anyway. So I'm going to delete these, hop back into the liquid, and parallel to this, I'm going to do a dot import. And where it says dot network, you can either search for it here, but seeing as this is right here, I'm just going to click and drag the dot network straight in to the import. And then I'm going to go ahead and under objects, it's not recognized next when on the start frame, so if we go to 32, it will recognize it. And instead of asterisk, which means everything, we're going to export only the flip fluid object. So we only want the fluid. We don't want the colliders or anything else like that. So we're only going to get the fluid out. So we're going to go ahead and start meshing this. I'm going to go ahead and file cache it first, the simulation, so we can just view it. We're going to name this bottle liquid cache, because that's what it is. It's a simulation. This actually only starts with frame 34, so to change that, I just did the control shift click to get rid of the expression because it says frame start and frame end, which is what it is by default. Gonna get rid of that and start it on frame 33. Sorry, it starts on frame 32. There we go. Just got to double check which frame your simulation starts on. So frame 32, I'm gonna not add any substeps for now, and I am going to save that to disk and let that cache out so we can see how it goes. And once that's cached, you should have something like this, where you can see it hit the wall, splash, and drip down, all that good stuff. Again, bear in mind with the simulation, when you have the particle separation, make sure it's something your system can handle. Obviously, the lower this number is, the longer it'll take to simulate. And if you have a decent enough GPU, you can actually go into the flip solver, volume motion solver, and you can use OpenCL to help you calculate some things, I think, like the viscosity and pressure. So that'll speed stuff up as well a little bit. But otherwise you're just gonna have to simulate it and wait. Thankfully, you don't really need a super high res simulation, fluid simulation for this Molotov effect, because we're actually not going to be rendering the fluid. I mean, you can if you want, but if you look at videos of Molotovs going off, you're not seeing these globs of fluid in the air. So we're not going to be rendering them. You won't see them in the air. You won't see them land. Of course, like I said, you can, if you so please. I'm not going to stop you, but we won't be doing that here. So you don't need a super high fidelity fluid simulation. After that, I'm going to drop down a time blend. You can drop down a read time here as well. It's the same thing. And if I put that on there and I go down here and click on the fractional frame playback, you'll see that that gives us all subframes for free. If we go to our cache, we'll see we don't have any subframes. And then we go to the time blend, we'll see that we have subframes. Just by dropping down there. And the reason we have these subframes, or substeps I should say, basically for free, is because we simulated with the ID attribute on, which you can see right there in point attributes is ID. We have consistent IDs, so we're able to interpolate where they are between frames pretty accurately. So that will save us a little bit of time instead of caching the fluid with a bunch of substeps. Now we're going to cache this. It's again up to you completely. You could use a I think it's particle fluid surface and cache it that way if you want. I'm going to cache it the way that I prefer, which is by using the VDB. Oops, that is not. Is by using the VDB from polygons, from particles. Sorry, and we're going to go ahead and bring the maximum radius down. Because initially when you bring it in, you won't be able to see, and if you look at the error, it says change the minimum radius in voxels. So we're going to change that until we can see it, and then we're going to go ahead and hit a voxel size of 0.02. You can see it's pretty blobby and kind of gross looking. That's okay. We're going to fix that in a second. So we're going to go drop down a VDB reshape SDF down after that, and we're going to have that set to dilate as well. And that's just going to kind of inflate everything a little bit. So I think I'm going to leave that as is at the default setting. And then I'm going to drop down a VDB smooth SDF. And that's going to smooth everything out a little bit. You can see we haven't changed any settings yet, of course, but you can see that we lose a lot of the fluid. Bear in mind that when we convert this back to to polygons, you will get back a little bit of detail. So don't worry too much, but we are going to change this a little bit so we're not losing quite as much detail. And obviously you can change these as well. Lapation flow, that's through a little bit more, but it's a good idea to play around with how many iterations of smoothing you want. Again, I'm not going to be rendering this, so I'm not looking for a super smooth, beautiful mesh. What I'm going to be using this for is basically painting where I want the fire to be, and obviously we'll be setting the fluid on fire as well. So I'd say I want a fair amount in. I think I will set that back to Appalachian flow, and I'm just going to drop down a convert VDB just so we can see what it would actually look like. I'm going to set it to polygons, and you can see as soon as we drop down to polygons on the convert VDB, we get a lot of detail back that we don't see in the VDB smooth. So just keep that in mind when you're working on the VDB smooth, that it's not super representative of what you're going to get at the end. So I'm going to leave that on Appalachian flow. I'm happy with the amount of detail we're getting coming through there. I'm going to put this back on smooth shaded, and I'm going to go ahead and cache this. So I'm going to go a file cache, and I'm going to name this meshed fluid. And I'm actually going to save this with some sub steps, because even though we have the retime on this side, if we go back through, you'll see it's got those nice in between frames. When we cache this, it's not going to keep those subframes. And when we're using this to source our Pyro, you're not going to want to read this in all of this whole operation in every frame. So we're just going to cache it with, I'd say like 4 substeps, and that should be sufficient. We'll use like a velocity blow if we need to, stuff like that. And now I'll make it so that it doesn't have the steppy emission, which will make more sense later. But for now, mesh fluid, I'm happy with that. I'm going to go save the disk. Now that we've got that cached out, if we go ahead and look at the display flag and put fractional frames back on, we should see that now we have not a subset every frame, but we have enough that emission should be pretty smooth for the Pyro Simulation. So I'm going to go ahead and turn that off, and we're going to drop down a null, and you guessed it, we're going to name it out meshed fluid, just like that, and we are basically done with the fluid now, and it's onto the Pyro. So we're going to drop down another geometry container on the OBJ level, naming it Pyro, and hop inside that. Again, just a reminder, I will be using Axiom for this tutorial, but in the project file, I do have a version that uses no Axiom. It uses the vanilla Pyro solver. So again, if you followed along, don't worry, you can still do this in Houdini. All the sourcing is the exact same. The only thing that I do differently is the Pyro Simulation itself, and Axiom is just a lot faster, especially on the 5090. So that's why I'm going to be using it. But if you don't have Axiom, don't worry. The first thing we're going to do here is import our fluid mesh. So I'm going to do an object merge, and I'm going to go ahead and grab our out meshed fluid. I'm going to color this. So basically, it's going to make more sense in a second, but what we're going to do, it doesn't matter what the color you choose for this, by the way. But what we're going to do is use the color from this and spread it onto a wall. So we're going to use this to paint our wall orange in all the places that it touches, kind of like a wet map. And then that's where we'll source the wall fire from, as well as sourcing it from the liquid. Doing this basically allows us to have the liquid itself on fire, but also everywhere the liquid has touched at the same time. So if this part like drips down, like everywhere that it has touched on the way down will leave a trail of fire, as opposed to only the blob being on fire, if that makes sense. So we're going to bring the wall in now. We're going to do another object merge. Let's name this as well. Let's keep our things named. I'm going to name this import fluid mesh. And we're going to grab this one, and we are going to go ahead and grab our wall. And it's a good thing that we left an out wall earlier, so we can come and grab it. And then the way we created collision with the floor, we never actually made a floor, because we did all of the floor collisions in the solvers. In the flip solver, we used the ground plane, and with the RBD and Vellum, we used the ground collision in the solver itself. So we don't actually have a floor, so we're going to quickly create one to use here. So I'm going to drop down a grid. That is not a grid. Drop down a grid, just like this. And I'm just going to scale it up here. The way I'm scaling up both fields at the same time, by the way, is I'm hovering over whatever parameter I want. So in this case, size, holding down middle mouse button, and then you can choose the increment you want to increase it by. And then I just go move it to the right to increase, move it to the left to decrease. I don't think I mentioned that this tutorial. But that's just how I'm doing that. So I've got my grid and the wall. What I'm going to do is I'm just going to merge both of them like so. And I think I will probably give my grid a little bit of thickness. So I'm going to go for a poly extrude. I'm going to put that just under the grid, and we're just going to extrude that. I'm going to extrude it down just because I don't want to have it come above the 0 level of the floor. And I'm going to click output back to fit it up. I know it's inverted, but it's not really going to matter because we're going to convert all of this to VDB. If you want, you can put a normal mode down and flip it. There's no reason at all to need to do that though, because we're just about to hit it with a remesh. So I drop down a remesh node after this, and go ahead and remesh that. At first, you're not going to see anything happen because we don't have wire shading on. But if you go ahead and turn smooth wire shading on, you'll see that we can now see the before and after of the remesh. So these are the polygons we have before, and this is what we have after. This is pretty fine, to be honest. I might even make the target size a tiny bit smaller. The reason I'm doing that is because the more polygons we have, the basically higher resolution our paint map is going to be. And this will all make sense in a second. So for now, I'm going to drop down another color, Again, made it something different. Doesn't matter what it is. I'll make it like hot pink. Now I'll paint all of that. And let me just drag this down so we can see what's going on. And what I'm going to do is drop down a solver. And I'm going to show you why. So I'll actually do it outside the solver first, and then I'll move it inside the solver, just so you guys can understand why we're doing what we're doing, and it'll make a lot more sense. So we're going to drop down attribute transfer. And on this attribute transfer, we obviously want to transfer color. And in Houdini, color is CD. So we don't need primitive, we just need points, and we need CD. So on the left, it's required geometry to transfer attributes to. We want to transfer this color to this wall. So we want to plug the wall in on the left, because what we're transferring attributes to, and we're taking attributes from our splash. So we go ahead and put the display flag on the attribute transfer and play. You can see we have this huge orange mass taking over a wall. What we have to do on this is come to the conditions on the attribute transfer and bring down the the distance threshold. And if I put a template on the mesh, you can see where to dial it into. So something like that is a bit more sensible. You can do the blend width however you want, but I like to keep it pretty close. So something like that. And then that's basically all you need to touch. And then you can see, if we press play on this, you have like your paint map. However, when this drips down, so from like here to here, it's not leaving a trail. It's kind of like a projection. You're not getting the trail of where it splashed. So that's exactly why we're going to do this inside the solver. So what I'm going to do is I'm going to do Control X, which will put it on the clipboard, but we'll cut it. So just get out the way for now. And we're going to drop down a solver, just a basic solver. And we're going to plug in color 2 into the left side there, the first input, sorry, and then color 1 into the second input. And we're going to hop inside the solver. And then we're going to I'm just going to press L and sort this and move these out of the way. We're not going to be, actually, we'll be using one of these. So let's just move these up out of the way for now. And what we want is input 2 and previous frame. And if you remember on input 2, we have our fluid mesh. So that's going to be our paintbrush and this is going to be our canvas. So we want input 2 and we're going to paste our attribute transfer back. And we're going to plug this in here. So basically what we're saying is we're going to take every previous frame of this mesh and run that operation on each one. So when we come back out and look at the solver, it should stain it on every frame, and we have exactly that. So now you can see it has that drip and that trail from everywhere it's touched. And this is also the same way you would make a kind of rudimentary wet map. So underneath the solver, we need to get rid of the background. This Saints Row purple. We only need the orange. So we're going to drop down and delete underneath there. And we're just going to do a little expression. We're going to go ahead and change this to delete by expression. And we're just going to write something really simple. Is at CD, so we're referencing the color, is less than 0.2, enter. So we're deleting everything that is less than 0.2. So the reason that it isn't blasting actually, or deleting, is because I said the colors don't matter too much, but they matter a little bit. I said they need to be contrasting, but I don't think these are contrasting enough. So I'm going to change the wall just to black, and then go back to there, back to here. And if I go to the delete now, there we go. That should delete everything. So this expression works. Just make sure that they're contrasting enough, or just copy my exact colors. I have the wall as black and the paint mesh as orange. So after this, I'm going to drop down a file cache because we don't want this to be referenced every single frame. We just want to have it in memory, or on disk, sorry. So it's a bit quicker. I'm happy with that. So I'm just going to go ahead and cache it after I name it. Splash Saucy. Save the disk. Okay, and now that's done. Press play. You can see we've got our lovely little splash. So after this, we need to scatter some points onto our wet map, essentially, for lack of a better word of what to call it. So I'll drop down a scatter node, and I'm just going to increase the point count quite dramatically here, something like maybe like 20,000. And there you go, we've got a much more defined shape now. You can see it's quite fast. If for some reason your scatters are being slow, you can turn off relax iterations. You won't get as even scattering, but it will be a lot faster. But for now, it seems to be fast enough, and we are of course going to bake it anyway in a file cache. So it's not too bad. But this seems fine for now, and I zoom in, it does seem a little sparse, so I might increase this to like maybe 40 to 50,000. I'll try 50,000. We can always come back and increase it later. And then we're going to add a few noises on top of that to make our sourcing a bit more interesting. So the first thing I'm going to do is drop down an attribute noise, like so. And we're not changing the CD, we're going to be changing the density. And I believe that is a float, so I'm going to want to change it to that. If you would like to see the effects of what you're changing, go ahead and hit the information, and on density, just tick that on so you can see exactly how we're changing the field. So I'm going to go change this. You can change the amplitude of how strongly you want it to vary, but we're interested in the animation so that when it's going through, it changes. I kind of would like it to happen faster. Maybe not that fast. There we go. Just so that the randomization of the density moves throughout. And you can change the element size. We can have the first one be quite a big one. And I'm going to actually lower the amplitude just a little bit, because we're going to add another attribute noise anyway. And then we're going to do an attribute randomize on the P scale. So we're going to set this to P scale. That's a POS scale, which is something else entirely, I suppose. So we're going to go to P scale, randomize that attribute. I think I'm happy with all of that. And then we're going to drop down another attribute noise. You can drop down 1 million attribute noises if you want for the density, and get it as complex as you would like. It's really up to you how you want it to look. So I'm going to drop down another one, and we're going to set this to 0 centered, just so that we can mix it with the original one a little better, as you can see, like that. And we're going to make this one like a lot smaller, and of course we're going to animate this. So maybe we'll have this one be like 0.5, like, or 0.3, oops, or like 0.35, and we'll have the first one be a little bit slower at like 0.7, and that'll get us some funky movement. It kind of looks like a chameleon shifting a little bit. A very trippy one. We'll drop down a point velocity just to inject some interesting velocities into the simulation. I'm also going to take off density so we can see the point trails. So I'll tick that, and then we're going to go ahead and add some color noise. We're going to increase the scale. I kind of want it to stretch up a little bit, so I'm going to add some basic noise. Set the value, and maybe just like something like 5 or -5 in this case. And you can do this with the conical noise instead, actually, and that will probably be more interesting. So I'll have this go up like -5, something like that. Yeah, there you go. And then push everything up like that. And we can play with the swirl size of this. Oops. Make sure to turn compute from deformation off and just set it to a value. Otherwise, it's going to try and interpret the movement of the points as velocity, which is not what we want. So you can see we've got some nice swirls, and I think that will be good for velocity. So I'm going to turn point trails off, and rasterize all this. So I'll drop down to volume, rasterize attributes, and I'm going to rasterize density, if I can spell it right. Density. It would help if you type into the right field. Density. I don't know where the floor went. There we go. Just visual bug, I suppose. Density, and then of course you can do the velocity as well. I will hold off on the velocity for now. I will source it, but just for now, I'm gonna sort out the scale of our sourcing. So I'm gonna bring this down the particle scale so we can actually see. Maybe set this to like 0.02, and then let's set this something a bit lower. Maybe 0.15. That's good. You can always come back in and change this. And you can turn velocity blur on. It's going to make it pretty funky. So I'm going to leave velocity blur off. And then I'm going to go ahead and source in the velocity. And then we're going to cache all of this. So we're going to do a file cache. And I'm going to name this Pyro Source Prep, because this is all of our preparation for the wall pyro. Obviously the fluid pyro will have its own. So maybe we should call this like wall pyro source prep. Just before we cache this out, I want to uncheck simulation because it's not a simulation. We can jump to any point without having a cache in between. So that will save you a lot of time. You just untick simulation and then save the disk. And now we've got that cached out, we can move on to the next thing we need to source, which is going to be the fluid pyro source. Now you might be wondering why we're sourcing the fluid pyro and the cloth pyro separately instead of doing them all in this, joining them all in this one. You absolutely can do that. There's no issue with that at all. I just like to have them separate in this case for the tutorial, so I can explain what I'm doing in every one and why. And two, just because I have greater control over each individual one. I might want slightly different noise on one of them. I might want the volume rasterized attribute to have a smaller voxel size or bigger voxel size on another. That kind of thing. So it just allows you greater control. But of course, you could source everything into one and then just throw it into Axiom there. It's no problem. But I will be sourcing them separately in this case. So we're just going to do the same thing again, but for our fluid source. So object merge. I'm going to name this import fluid mesh. Yeah, it's, I guess the second one, but it's fine. Then I'm going to go ahead and go to my liquid and get the out meshed fluid. Instead of scattering, I'm actually going to do a points from volume, because instead of scattering on the surface, I want to scatter within the volume. I'm going to change this tetrahedral and do something like 0.02. And you can see that's filling that out nicely. I'll use the same densities in this case, but if I ever wanted to adjust them separately, then I could do so. The point velocity will just steal the whole thing, and then we'll change some stuff on the volume rasterized attributes. So let me just take the V off for now so I can see what I'm doing, and I'm just going to make these a little bit smaller. 0.105, 0.075, something like that. And that should be fine. Let me add the V back in. And that should be good. Again, like I said, you could definitely just grab this and merge the points from volume with the scatter and use the same thing, but I like the greater control. But you can feel free to do that. And then I'm going to drop down a file cache. I name this fluid pyro source prep. And I'm probably going to add some substeps on this so that when we simulate it, we have some nice in-betweens, because of course we need to cache it so that we don't have to go through this every single frame of simulation. So we can't keep the substeps from earlier, but we can kind of carry them through with adding 4 substeps, at least in my case on the geometry. Again, this is not a simulation, so I'm going to go ahead and save that and hit save to disk and simulate that out or cache that out. Now we've done that, we'll do it one more time for the cloth. So we're gonna, or the rag, whatever you want to call it. So I'm gonna do a object merge. I'm gonna name this cloth import. We're gonna go ahead and grab that out cloth. And for this cloth, let me go to the first frame. I'm gonna select just the bottom of it. I'm not gonna use any fancy method. I'm just gonna use the lasso select. Or lasso rather. So select this, click and hold, lasso picking, and I'm just gonna select the part I would like to be on fire. Nothing crazy. It would help if I did the operation I wanted, and then I'm gonna go ahead and press delete. Just make sure you're hovering over the viewport instead of the node network, where you delete the node. And then in the selection, I'm going to go ahead and hit delete non-selected. So we have this part left. So I'm going to go ahead and hit a scatter. Because this moves so fast though, I might want to add a trail node. So I'm going to add a trail node like so. And let's go to somewhere after it takes off. So let's say around here. Let's do a connect as mesh. There we go. Do a connect as mesh, and then we'll scatter on that connect as mesh. That way we get this kind of fake motion blur. So we don't have to use as many substeps in the Pyro solver. And this will make more sense when we get down to it. But for now, we're going to leave that in there. We're going to scatter on top of this. I'm going to scatter more points, of course, maybe like 50,000, something like that. Maybe even, that's just 5,000, I was wondering, it's not many. 50,000, that's more like it. And again, we're going to do the same thing over here. Grab these. I'm actually going to adjust these ones though, however. So let me get the density, like such. Bring down the element size for the smaller, for the smaller scale, because we're on, it's a smaller scale. It's just going to be the cloth or the tip of the cloth. So I'm going to do that. We're going to get the point of velocity again. Let's turn off the density preview, or visualization, I should say, and turn on point trails. I'm going to change the curl noise so the scale is a little smaller, and we're going to change the swirl size as well on this one. So it's something like this instead. I go back to the first frame. So it's something like that. I might even make the swirl size like 0.7. And then I'm going to go ahead and hit it with another volume rasterized attributes. So make this one something like that, maybe 5.5. Hit with the density and the V. We might want velocity blur on this one. Let me just have a look. I think because of the velocity we've put on it, it's probably best we just leave the velocity blur off for now. We can always come back and turn it on. And then I'm gonna hit it with, you guessed it, the file cache. And we're gonna name this cloth. Cloth Pyro source. And we're gonna untick simulation. I hope I typed cloth correctly. There we go. Now I'm gonna save the diff. Okay, now that that's done, we can focus on these two. This one, because of the scale of the fire, we're actually gonna put into its own simulation. So we're gonna worry about these two for now. So we're gonna go ahead and hit merge on these two. And then we're gonna drop down a name attribute. We're gonna target density, and we're gonna name temperature, so we can get that attribute in the simulation. And then we're gonna plug this directly into an Axiom solver. Before I do that, I'm gonna go to frame 1 so it doesn't start baking. An Axiom solver. It's gonna give me an error. That's okay. I'm gonna run this on CUDA. If you have an NVIDIA CPU or NVIDIA GPU, then it's worth running it on CUDA. It's just a little bit faster, and we can start this. We know that the flames don't start until a certain frame, so there's no point starting the simulation until then. So on frame 32 is where we will start the simulation. So start frame 32. We go ahead and press play. Help if we put the display flag on the solver. We'll see we have got some stepping, but we also have basically no substep. We have one substep, so we'll worry about that shortly. But you can see we are getting our pyro sourced in. It's only coming in as this big billowy smoke at the moment, and we have no collisions, but it is sourcing it. So let's take care of the collisions first, and then we'll take care of everything else. An object merge straight away, name it collisions. And then what we'll do is we'll add a null after the merge before the remesh, and then just, well, we'll put it off to the side and do this. There we go, before the remesh, and we'll just name this out collisions merged. Cool. we'll just come down here and reference this in the Pyro, our collisions merged. And then we need to put this into a VDB from polygons so that Axiom can interact with it as collisions. And we need to go down to fog VDB instead of distance and name this collision. And now that I should be able to read that as a VDB. And you can just plug as a collision, sorry. You should be able to just plug that straight into the merge like so. Oh, excuse me, like so. So we roll this back, go to the Axiom solver. We should see it colliding. And it's not looking like we are. Let's turn this grid off. It's looking like it's just ignoring that. So we are going to figure this out. And that's because I spelled collision wrong. So sometimes when you try and type fast for the tutorial, make sure that it's spelled correctly. And we press play again. We should see it colliding now. And immediately we do. We can see that sharp cutoff on the side and on the bottom. If you do notice that the floor collider is cutting off your sourcing, just move your grid down like a tiny bit so that you have a little bit more space. It's not going to affect anything like crazy. It will just give your emitter a little bit more space to emit. And I'm in the wrong place completely. There we go. And then you can see my floor emitters now have a little bit more space to actually emit upwards. So you can see that's working now. It's a bit slow because of the division size. And I don't have any dissipation on at all. So all the smoke that is being sourced is not going anywhere soon. But it is sourcing everything, which is good. Other Pyro videos, I've gone over the settings needed for somewhat realistic fire in Houdini. So I'll go over it again in this, but I'm not going to make a huge point of every setting. And if you want to see that, you can go and check out my house fire tutorial in Houdini, and I'll go over in that one how to get realistic fire. The project file for that one is available as well if you want to dive into the settings. So I'm just going to increase the timescale because for fast fire, you need faster timescale. And I'm going to increase this, change this to frame step and frame step so that it scales with the timescale properly. And we can press play on that. You can see that it's still not quite fast enough and the dissipation is too low. So I'm going to increase that to like 0.5. Press play. And turn this grid off as well. Whoops. Oh, and my Houdini just crashed because I pressed the wrong button. Okay, no worries. We'll be back in a second. So we are back. Don't know why that crash just happened, but we keep it moving. It didn't save my last settings, so I'm going to go ahead and set this dissipation to something like this, and maybe increase the cooling rate a bit as well. And we will add some disturbance, of course. So disturbance 1, disturbance 2, and turbulence 2 as well. Add some confinement and turbulence 3. I'll leave turbulence 3 off for now, just so we can get a decent idea of what we're looking at. Of course, the disturbance is too high, so let's hit this with like a 0.2 and like another 0.2, so I can see where it's at. Okay, let me turn these off so I can get a better idea of which one is doing the heavy lifting here. Okay, so this disturbance needs to be turned down. I also would like a bit more fidelity so I can see what I'm doing. So I'm going to decrease the division size, come back here, and not 21, that's for sure. That's too much disturbance. This is also too much disturbance. 0.5, and let's get a substep in there. There you can see with just 2 substeps, we're getting a lot better stepping or lack thereof in the sourcing, but of course we'll increase that more later. It's just so we can see what we're working with. And it's not bad. The curl noise that we got the velocity from is it's giving this really spooky, twisty effect. So I'm gonna go back in and add just a bit more disturbance, and I'll add a second disturbance, and we'll see how that goes. Yeah, that's a little bit better. Again, we are creating just the fire at the moment, not the smoke. We source the smoke from the fire. I'm just getting the general look before I cache it, because it's a lot quicker. Axiom is a lot quicker cached than it is in the viewport, obviously, because then you don't have to look at all these voxels load. So it's considerably slower in the viewport. One of the things I want to do in sourcing is I'm going to increase the density to like 2, temperature, maybe even the pressure a little bit, and the velocity. And I might put these on frame step, but we'll see how it looks first. One of the turbulences might be a little bit too high, but it doesn't look terrible. I still think this is too slow, but one of the things we can do on the solver to quickly just get a rough check is we will go to settings, change it to 16-bit. It will just make the file size slower with no noticeable change to quality. And then on the output, we're going to turn off temperature and velocity, just so that we can see where it looks like a bit faster. I'm going to name this Pyro Cache. And when we do the final, make sure to turn on your temperature and velocity. Otherwise, you're going to have no fire. So we'll come back and turn this on. But for now, we will connect these. And it starts on frame 34 or 32. So I'll start there. Save us caching empty frames, and we will just cache that and see the preview. Okay, now that that's cached out, it's complaining that I can't find anything because, well, there's nothing on the first 31 frames. So I'm just going to go ahead and ignore that, press play, and see our simulation. It's not looking bad. I can't get an idea of the motion though because of how slow it is. So we're going to do a trusty, I'm just going to frame this up like this and do a nice flipbook. So I come down here, click flipbook, make sure it comes to mplay, and I just press start. And when the window pops up, we'll drag it in, and we'll do a nice flipbook that we can watch back and see the motion. Just judging from what I can see here, I probably want like a little bit more buoyancy to bring the fire up, and I think I probably want it to be a bit faster. But we'll let it just come out and do its flipbook first, and then I'll make my judgments. There we go. Let's have a look. So the initial explosion is a little lackluster, but when we add smoke on that, we can add some pressure and make that blow up a bit more. So that's okay. The sourcing is nice. I'm happy with it. Again, we can add some sub steps, but this doesn't even look bad. A bit of motion blur, and you're not even going to see this stepping. So I'll let it play now. Sorry. So yeah, it's not fast enough just yet. It's in some weird swirly middle ground, but I'm happy with the disturbance and the turbulence for now. So I'm going to go ahead and switch this up and go and add some, increase the time scale, sorry. So I'm going to just double it. I should probably go by another increment, but I think this is okay. I will do a test. When you're working with these really fast time scales, by the way, it is wise to add more sub steps, but there is a kind of a balance. If you add too many sub steps, then you don't get that fast flicky fire that leaves those licks that you want. So it's a good balance. So I think this might be good. I said more buoyancy as well, so I'm going to go ahead and add that as well, just a little bit more buoyancy. It's like 1.2 or 1.3 maybe, and then we're going to go ahead and cache that back out. So that's done. It was only a couple minutes cache, so let's play that and see. Actually, you know what, let's just go straight to the flipbook. So let's go ahead and press play on that. I'll just go from here. There we go. That's a much more aggressive fire look. You're getting those flicks in the fire. You're getting that raging effect from the turbulence, from the velocity that we baked into the points. And overall, I'm really happy with it. I think it looks really good. I might add a tiny bit more velocity, but I think I'm really happy with it. And we even get a much better explosion now because of that buoyancy of that big puff upwards as soon as we start. So I really like that. I think that's good for the fire. You know, I might increase the time scale by like a, where is it? Like a 0.5 maybe. And I might increase the cooling rate like a tiny bit, like this. But I'm really happy with what we have. I haven't even messed with the turbulences that much. And to be honest, I don't think I'll mess with them much more. What I'm going to do is I'm going to turn our temperature and velocity back on and then lower this to something I can handle. The 5090 has 32 gigabytes of VRAM, so I have quite a lot of leeway when it comes to voxels. So I can probably set this to like something ridiculous like 30 million and be okay. So let's do like 0.45 and then let's just do like this to be safe. I have to want too many zeros. That is 139 gigabytes of VRAM, which I don't have. There we go. And that's about 13.9. I've got a bit more leeway to use more, but I'll leave it like that for now. No point being going crazy. And in terms of this simulation of just the fire of the splash, we're basically done. So we're just going to cache that out, double check that there's nothing I'm forgetting, and just cache that out and see how it goes. And that is done already. Axiom is just so ridiculously fast. That was a 2-minute 40 cache. So we're going to go ahead and see if it's any good. Here we go. Let's see how this looks. And I'm glad I did decide to make it a little bit faster. It is going very wild. And that would be because of the velocities I put in on the noise beforehand. But you know what? I do like how crazy they are, but I think I'm actually going to go back and change them. And let's just... Two things I want to do. I want to change the scale. So let's turn this down. What was it before? 6 point... This is half it. Just half it. And bring that in. And then the swirl size, I actually wanted to lower a little bit as well. Not too much, just maybe like a 3.5. Something like that. And I'm happy with this. And I will just do the same here. I'll just delete that and bring this in. Which means we'll have to recache both of these. But that is just part of the game of developing and art directing Pyro simulations. So I'm going to cache both of these, and then I'm going to cache the Pyro cache, and then I'm going to put the flipbook, and then I'll be back. And I am back. We have got everything cached and flipbooked, and let me move this fully onto the monitor. And this is what it looks like. Let's move it over here. So I'm pretty happy with the fire, the motion of the fire. I like how crazy it is, how wild it's flicking around. So we're going to go with this for the fire, and I'm happy with that. I could probably decrease the division size even more, and I might for like a final render, but for now, I'm happy with that. So we're going to move on to the next step. Okay, so what we're going to do is just do the same thing that we did here. We're going to set up our merge so we can get our collisions in as well. So what we're going to do is we're going to do the same thing. You can probably just take that over. It's the exact same. We're just going to turn, get a temperature attribute in there, and then merge that back in, like so. And then we're going to put that into an axiom. So I'm actually going to just grab this one. Then we are going to make some slight changes to the solver, because we want to make empty error window. That's good. So we're going to make the start frame 1 because the cloth fire starts on frame 1. And as you can see, we have, if we go to the rasterized attributes, go to like frame, there we go, frame like 4. You can see it's not really super accurate. So we're going to have to change some settings in order for it to be appropriate for a fire of this scale. But if you're curious, you just press play. You'll see that it explodes up like that. It's quite a big fire. It's actually going that way, so I need to go over here. And then it falls to the ground after being thrown at the wall. So we need to mix our collisions in, and then we need to also sort out the scale of the fire and the disturbance and all that good stuff. So we're going to go ahead and just duplicate this just because I don't want to have a line going across all of this. So I'm just going to make a copy, and I'm going to plug that into the merge as well, so that we have some collisions for the cloth. If we play this again, we should see it hit the wall. You can see, if I pause it here, definitive collisions on the wall, so you can tell that the collisions are working, and when it hits the floor, you can see it doesn't go below that point either, so it's working. But we have too much fire, it's going too high, so I'm going to fix that. So the first thing I'm going to do is go to the simulation, and I'm going to increase the cooling rate here, maybe like 0. Something crazy, maybe like 0.5, just so we can see. And I'm probably going to decrease the buoyancy because that's making it go up as well. And while we're here, let's turn the disturbances. Let me turn these off just so I can see which disturbance is going crazy. That first disturbance isn't actually that bad. I might lower that. I think it's the second disturbance that's going crazy. So I'm going to lower that second disturbance and see. And it is indeed that second disturbance. That is going nuts. So I'm going to lower that. I'm going to add the turbulences back in. I'm pretty happy with that. I want it to cool down even more, increase the dissipation. Yeah, that's a little bit better. And increase the cooling rate as well. So it cools faster every frame. Save that. And that's a little bit better. I think it's just also got a lot of velocities. So I'm going to just go in here and I think probably scale down the velocities a little bit. Because they're going a little crazy. I think. So I'm just going to move this down to like 1, and then maybe this down to like 2, just half that. 2, and then the animated velocities, I'll just bring down to like 1. And I'll just leave the swirl size at 1 as well. I'm going to rebake that, and we'll be back in a second when that is recached. Okay, I'm back. I've just recached that all with the new velocities. And again, that's another reason I like to have them separate, because I just have greater control over everything individually. So I'm going to go ahead and turn the point trails off and go back to my solver and see how that is looking now. Okay, still spewing around like crazy. These disturbances are also still way too high. So I'm going to hit with one of these, and see how that looks. There we go, that's a little bit better. I think I'm much happier with that. It's kind of going crazy on the floor there, which again is due to the velocities, but it's not too important because at this point it's going to be completely, well, I guess not completely, but it'll be amongst a bunch of other fire, so we won't have to worry about it too much down there. So if I play that one more time and see what else we can change. I still might lower these velocities just a tiny bit. Let me see, maybe these turbulences are also making it sway around like crazy, yeah. So those turbulences are part of the reason it's going crazy. Let me turn on turbulence 1 and see how much we need to lower that by. Turbulence 1 is, yeah, swinging it around a lot. So let's lower that. There we go, that's a lot better. Falsely accused the velocities we baked in when it was the turbulences the whole time. But that's okay. So I'm happy with that. Cooling rate is all good. Buoyancy is fine. The trailer leaves is kind of a little bit longer than I would like. And what we can do is go back to this trail and lower the trail length, or the increment. But I'm going to leave it for now just because I don't want to go back and recache all of that stuff. But all of this stuff is really easily modifiable and art directable. You can just go back up the chain and recache it and then come back to the simulation. And if you're using Axiom, you can see it's super fast. But I'm pretty happy with that. So what we're going to do is make sure the settings are all good. Yep, 16-bit, and it is outputting everything that we want. Just because this is smaller, I'm going to increase, or I guess decrease the division size, something like this, and see how that is. You won't be seeing this fire close up, so I'm not too worried about it, but I do want it to be good quality, so let's get that like a 0.02. So it's very, very small scale fire compared to the last one, so we need to bring the division size down even more. That one's probably okay for fire to scale. We're going to cache this out, and then I'm going to do a flip book so we can actually see exactly how it looks. So I'm gonna name this one Cloth Fire Cache. And I'm happy with those settings because it does start on frame 1 and it is a simulation. So I'm gonna go ahead and press save to disk. Go back, that has cached out. I just want to get the framing right for this flipbook, so we can see where it's gonna end up. This one is actually lightweight enough to play in the viewport, so we don't need to flip this actually. You can see that is the fate of the cloth. The turbulence still might be a little crazy on it, and also maybe the time scale is a bit insane too. I know it does match the time scale of the one before. I'm just going to drop it to 4 and then recache this quickly, or maybe even a 3.5. But we could tweak this all day, so I'm going to leave it at 4 and just cache this again real quick. Okay, so that's finished caching. Let's have a look at that again. It's still maybe a little bit too fast. Smaller scale fire does flicker faster, so it's fine. I'm probably just overthinking it a little bit, but I would likely tweak it a bit more. But that is fine for now. We will leave that as is. And for any of these fires, of course, if you want to see how they would look like, I'm going to use the big fire for an example. Go somewhere like this. You could drop down a Pyro Bake volume and drop that down underneath and turn off smoke and go straight to fire. It will look crazy at first, but just bring down the source, the intensity scale for now. And I'm going to just play with the graph a little bit. You don't need to copy this right now because we're going to recreate the whole material in LOPS anyway. I know you can create material from the Pyro Bake volume mode, but then I have to keep hopping out of LOPS to change it. So I don't want to do that, but we'll make it look something more like this. Again, in the rendered view, it will look a lot better. But if you wanted to see what the fire looks like, then you could drop down a Pyro Bake volume mode, and you could play with stuff like that. You also have the density. Of course, we're not using this as smoke, and then you have the scatter as well, which goes along with the smoke. But again, we are not going to be using any of this stuff. Well, not the smoke and the scatter. I'll be using the fire, but that is for later, or shortly, I should say. So now we are going to source our smoke using this fire, the big fire. That's how we're going to get the smoke to come off of it. If you look at some Molotov cocktail reference, you'll see that there is some smoke that comes off of it. It rises up quite quick, and it's usually quite dark. And I suppose that depends which liquid is burning on the inside and which surface is burning on, but it does help the fire look better when you add some smoke. So after this, we're going to drop down a convert VDB. Now what I should have done in this tutorial was render this as a VDB or cache this as a VDB. Then we wouldn't have to convert it, and in the project file you'll see I did in fact cache this as a VDB to save this step. That's okay, we'll just convert it to a VDB because we're going to need that so we can do the VDB resample. So that's okay, we'll convert it and we'll drop down a VDB resample, and in the convert VDB just make sure you change it from volume to VDB. You can leave everything else the same, and then the VDB resample, let's move to a frame where we can actually see, there we go, see the volume. And then in VDB resample we're going to go and change it from define transformation or define transform to use voxel size only, and you can see it makes it really low res. So we're gonna, which is what we want. We don't need the full resolution of our simulation to source the smoke. We just need like the rough shape and the velocities. So something like this is probably fine. You could probably get away with like 0.5, honestly. I'll do like 0.45, but play around with this and see the kind of shapes you get. So now I'm gonna do 0.45. You'll obviously get more defined shapes from something closer to this, but for the sake of speed, maybe I'll just do 0.35, and that's okay. You know what, 0.4. There we go. And then you can actually just, because we have everything we need, we have all the volumes. You can see we've got density, temperature, all the attributes, sorry. You have density, temperature, and vel. We don't need to add a name and add like temperature or anything like that. Not that we need temperature anyway for the smoke. So we'll just go ahead and drop this straight down into a file cache. And we are going to name this, smoke source. And we don't need this to be a VDB. The only reason we needed this to be a VDB is so that we could hit it with the VDB resample. But now we've got what we wanted, we can just go back to the bgeo.sc, which is just a nice compressed file format. And this is in fact not a simulation, so we can turn simulation off so we can do some more efficient caching. And I think that's everything we need. We can go ahead and cache that. So we have gone ahead and cached that. Now we have our smoke source, which is just a lower resolution of our fire sim basically. So now we can go ahead and drop that into an axiom solver. Get that out of here. I don't know why that keeps popping up. And we know this starts at, whoa, what's a lot of substeps. Please do not crash my Houdini. There we go. We know this starts at frame 32. So we'll just start at frame 32. There's no need to calculate 31 frames of nothing. I'll jump onto the solver. And we will press play and see what happens. So you can see it's starting to source some smoke. It's a bit slow. I'm going to turn the division size down just for some speed real quick. I'm also going to set this to CUDA. There we go, it's a little bit faster. A lot bit faster. Now you can see we're getting some big billowy smoke, which is of course because we haven't adjusted the timescale or anything else. But first we can see we have not got any collisions. So we'll do the same again. We will just go ahead and yoink these. And we will drop down a merge just before the solver. And we'll drop the collisions down into there. And as long as you've got the VDB from polygons named collision, you don't need to worry about which way it's plugged in. I just always like to untangle them aesthetically. But you don't need to. Okay, now we press play. We should have some, yep, we have some collisions. You can see it actually goes over the top of it, which is fine. But we need to do a few things. So first thing we need to do is increase the timescale. We don't want it to be as fast as the fire. I think our fire is 4.5. We don't need it quite as fast as that. We can set it something like 2.5 and see how that looks first. Let's have a little look. So that's a little better already. I might go ahead and put that on 3, and I'm going to increase the dissipation just a little bit. Well, that's actually quite a lot. And we're going to see how that looks as well. Again, we're still going to add, you know, disturbance to break up the mushrooming and all that good stuff. So it's a little wispy now, but don't need to worry about that too much. I will decrease this a tad. Okay, still very mushroomy, but we haven't added any disturbance in yet. And one of the things I want to do is go to the sourcing and increase the velocity and put that on the frame step and see how that looks real quick. I want to be kicked up by the, there we go. That might be a bit too high. Setting that one sky high, and also it being on frame step will scale it as well. So I will keep it on frame step, but I will just lower the value to like 2. We'll save and do this and see how that looks. Okay, not terrible. I'm going to increase the density sourcing a tad, and the pressure as well, and see how that looks. You can keyframe the pressure so that as soon as you get this hit, you keyframe the pressure to be really high, so you get that big like poof, and then you can lower it back down. I'm not going to do that for this tutorial. So now that it's shooting up higher, I do want to increase the dissipation even more so that it's not going up into the stratosphere. Just because we're not going to render up there, and it's just going to slow down the simulation if we have voxels that are going out of frame. And while we're here, let's just add some disturbance as well, so we can get rid of some of this mushrooming. We'll add some turbulence in there as well. That disturbance is okay. It's a little strange on the edges, but it's okay. We'll get some turbulence in here as well. Again, apologies for my voice throughout this tutorial. I know it's not what it normally sounds like, but I just wanted to record this tutorial and get it out there and get it to the people. There you can see the velocity is going crazy and whisking it up really high. So again, I'll just lower the velocity sourcing to like 1.5 maybe, and we'll see this. And the pressure may be a bit too high as well. Okay, a little bit better. Just 1.5 to 135, and then maybe 135 on this as well. I think what we need to do is cache this and see how it billows up in the flipbook, so we can see properly. I'm just gonna double check some more things. I kind of want some crazier turbulence though. I think actually the first turbulence field is the bigger one. I can check by just going down here and seeing. So turbulence 1 has a source size of 0.5, and then turbulence 2 has 0.2. So yeah, turbulence 1 is the bigger turbulence. So I'm going to set that to 2, press play. Okay, still a lot wispier than I would like. Set something crazy like 10, so I can see the effect of this turbulence, because I really want to see what it's doing. Okay, it's really hard to see what's going on. I'm going to add a tiny bit more disturbance, and then we're going to cache this out so I can see a little quicker. So I'm going to hit a file cache, and then I'll name this smoke cache. Happy for it to be BGO. It is a simulation. It starts on frame 32. We don't need any substeps with that, so I'm going to go ahead and save the disk. Actually, I lied. I'm not going to save the disk yet. I know Axiom's upset with me for cancelling that bake. But I'm going to change the output to density for speed, and then I'm going to change it to 16-bit. There we go. Now I'm going to cache it out. So that's done already. It's crazy how much faster it caches when you're not using using the viewport. So let's see this. It's still a little bit slow. It's getting definitely way too much velocity. So I will. I don't even need to look at the flipbook for that to know I've got to turn that down. So I'm gonna do that first. Okay, I'm back. I did a lot of fiddling, so I decided I would cut all that instead of adding like 15 minutes to the video. But if I do a quick little flipbook, this should probably be in frame like this. I'll explain to you what I did in just a second. Okay, let's have a look at that. So you can see it's a lot better now. It still gets whisked away quite a bit, and I think I will increase the density of it. And I still have that initial kind of mushroomy burst, and there are a few ways to get rid of that. I feel like that could be its own video entirely. Other than that, I'm pretty happy with it. I would like a bit more density, so I could either increase the density sourcing here, which I already did off camera, or increase it in the shader, which I'll probably do in the shader. But for now, I'm happy with that. All I did was I changed the density, I changed the velocity and pressure back to 1. Honestly, you could probably even lower this like a tiny bit. And I just might, even though I said I was done tweaking it, my bad. And then other than that, these are the settings I used. I left the turbulence pretty crazy high because I wasn't getting it to break up like as much as I wanted. So I went a bit extreme with the turbulence. So I can get some more crazy movement in there, and I think that did help quite a lot. You can't copy these settings exactly and get this. You need to play around, because I've made this project file 3 times. One to figure out how to do it, once, well, I guess 4 times. Once to make it the project file for you guys to download, and another time to do it but without Axiom, and then now in the tutorial, and each time it's been a different outcome. So you can't copy these settings exactly because you're going to get something different. So you need to play around and find what works for you. And if you're using Axiom, that should be pretty quick anyway. So now we're basically done with all of the Pyro and, in fact, everything else. So it's time to render now. We're going to render this in Karma. I'm going to show you guys how I set this up. We're going to be doing very simple materials. We're not putting any like fingerprints or displacement on anything. Just very simple setup to show you how to do mostly the shading for the fire in Karma. So we're going to drop down some nulls after the things we want to render. So after the cloth fire, I'm going to drop down a null just so I can grab these easier after the fact and bring them into lops. So this is going to be out cloth fire, like so, and then I'm going to do a null here and I'll name this out smoke, just out smoke actually. And then I don't think I have one for the pyro. So we're going to do a null here. And have that be called out fire. Just real simple. And then I think that's all of the pyro taken care of. So we're going to make a render stage. There's a couple ways we can do this. I think one of the easier ways is to actually just have a pyro bake volume and to just initialize in quick steps, create render stage, and then choose like a light preset. We can change this anyway. I'm just going to do daylight for now. And that will actually make the LOPS network for you and all the base stuff for you. I'll go down what these all do, but it's pretty simple. And then I'll make it right here. In this case, I'm going to I don't need those, so I'm just going to delete them. Thank you for your service. And this is the LOPS here. I'm just going to name it render stage. And this is where we're going to import everything. So let's start with, if I go back, it's just mad because we haven't saved it. So there's a few things I'm going to change. First thing I'm going to change is change the output. Is because I want some calmer render settings. So I'm going to put that down as well. Actually, if I just drop down a calmer, it should give me both, yeah. So for some reason, this calmer, I don't know what it is, but when you're rendering with XPU, so GPU, this just hasn't given me the results I wanted, the speed I wanted. That's kind of weird. So I just normally get rid of that and then use the calmer render settings, like so. And you can access that by again, just typing calmer in, whoops, and then you drop that down, or you'll get both of them. And this warning is just because I haven't saved. So if I just save, then it'll go away. I don't know why it does that after every change, but it's not really a problem. And then here we can change our settings, but we're getting ahead of ourselves. We'll come down to this. The first things we're going to want to do is set up our sources. So the things we're going to import. So everything we've created so far. So let's hope that you've kept your file structure up to par, because we're going to be referencing a lot of things. And if you haven't named them properly, it's going to be quite the chore to locate them. So I'm going to drop down a SOP import of one of many. And because there's going to be many of them, I'm going to drop down a merge and plug that in there. Plug this in here. And let's go find something to import. Let's go in the order we created them. So let's go find our bottle. So I'm going to go into SOP import, click on this, and I'm going to go to the bottle smash, out bottle smash. And there we go. You can see we've got our bottle smash imported. I'm going to name this bottle. We are going to create another SOP import, and I'm going to find what we made next, which is the cloth, out cloth. Name that cloth. You can see now why it was so important to to have everything named properly. Next, I'm going to go down to the liquid. Actually, we're not rendering a liquid. If you want to, it's completely up to you. That's fine, but we're not doing that. But we're going to add all of our pyros. So we're going to do cloth fire. You can see that comes in there. I don't know why it comes in so weird on the first frame, but it won't be a problem really. Then that cloth fire. You will get this weird warning when you haven't saved after you made the change. But again, hit Control S, it will go away. I just hopped out by accident, oops. And then we're going to go to the fire. This is just a normal fire. And then we are going to drop down another one. You get the idea. And then I'm going to get the smoke. And I'm going to name this smoke. So now we have everything imported. If I go to like frame like 60, 61, you'll see that we've got the fire and the smoke. It's kind of hard to distinguish them. If I turn off the smoke, you'll see the fire underneath, but obviously we'll get all that, and there's a little cloth fire underneath that. So we've got everything merged in here. I'm gonna go down the list now and show you what these will do. They're really simple. This is the render geometry settings. This is just where we're getting our motion blur from. That's all we're doing in here. You can do other stuff too, but that's a little more complicated, and we're not gonna get into that right now. I can get into the rendering of camera rendering settings in another video if people really want. But for now, I want velocity blur on. We have the velocity attribute in all of these. We've cached them in, so we will get motion blur when we render. Even with that, I still add motion blur in like After Effects with RSMB, and you can add in like Nuke with your vectors and stuff like that. But that's all we're doing here is enabling motion blur and velocity blur being on velocity blur. Next is the material library, which we'll come to shortly. This is where we're going to make all our materials, which is why I don't use the Pyro bake volume nodes, because I'll have to keep hopping in and out of this, and then I have to go to the bake volume node and hop back into the stage. I don't want to do that, so I make them all in this here. Obviously, we've got one basic one that we're not going to be using. We're going to be using Karma rendering materials, so we'll worry about that later. Then we have some lights, some dome lights. Oopsies, this one is slightly colored. One distant light, one dome light. We have a camera, which we will reposition. And we have our render settings. So very simple setup. We definitely could have made it ourselves, but it's just way quicker to use the render stage setup. So while we're already on the camera selected, if you have your display flag set higher than the camera, then you won't be able to see it up here in the top right where it says cam. It will say no cam. So if you put your display flag on the camera or lower, then you'll go up here and you'll see camera 1. So make sure if you don't see your camera pop up, that's why. What I'm going to do is I'm going to click on camera 1 and click tie view to camera / light. So what we're doing is basically just making sure that wherever we look is where the camera looks, so we can frame it a little bit easier, and then you can just use the normal Houdini viewport camera controls to get situated. So I'm just going to frame this up in a way. I don't really need to see the top of the smoke, so it'll make the frame a bit too big. But I think I'm happy with that. The bottle starts just over there to the left. You can see it. Throws into the wall, smashes. Make sure to come back and turn it off so that you're free without moving the camera around again. You can go look at this in rendered preview. So if you're using CPU to render, then you'll go to Karma CPU. I'm using my graphics card, so I'm going to use Karma XPU. And it takes a second to initialize the first few passes and everything, and then after that it becomes much faster. There you go, you can see it's sped up now. So if we move around, it'll be a lot quicker. Obviously we have no materials. These are just the lights that we have on. If I turn the lights off, then, well, you're not going to see very much. It'll go to, if you have no lights, it'll just go to this default volume, kind of gray, so you can still see it. But we have like our lights, so we're going to leave those on if you wanted to get an idea of how nice your volumes can actually look. But let's add some materials and assign them. So I'm going to put my display flag, I'll probably keep it down here on the camera. And then in the material library, that's where we're going to go crazy and do our stuff. So let's start with what we create first, which is the bottle. So we're going to create a new material. You can actually delete this default one it created with us. We just, again, made this so that we didn't have to make all these nodes separately. So I'm going to press add new material. It says geometry path. So I'm going to click the little arrow here and I'm going to select what I want. In this case, it's not on this frame. So I'll go back and select the bottle, press enter over the viewport. And now we've got the bottle in there. You can also just drag this up in there like that, but I'm going to reference it like that. And then we're going to go to where it says material VOP. We don't have a material created for it yet, so we're going to create one. So in the material library, I'm going to double click, hop in there. This default Pyro shader, I'm not really interested in, so I'm just going to delete that. I'm going to drop down a Karma material builder. Give it a second, press that down. I'm going to name it bottle. And then we'll hop inside of this, and that's where we're going to make some changes. I'm going to hit L just to organize this a bit better. And then I'm going to come out to the render stage, probably come to like the camera or something. And then I'm going to come into XPU view so I can actually see the changes we're making on the bottle, which isn't assigned yet. So now we've created that material. We can assign it quickly so we can actually see the changes. And I'm just going to select material library, bottle. There we go. So now we've assigned that to the bottle and we can see. I'm going to hop back into the material library, into the bottle, and most of the changes we're going to make are going to be on this standard surface material here that we've created. You can see if we change like the base and stuff, it changes live because we've linked it now. So first thing I'm going to do is go to transmission, and because it's a bottle, I want it to be, transmissive. I want it to be transparent. So I'm going to increase that. Give it a second. You can see that the cracks in the bottle are still present, which is kind of good because that means I can show you how to fix that if it does happen to you. So we're going to fix that right now. So we go back to OBJ level, go to bottle smash and go to the RBD disconnected faces. That is because we didn't change the mode. We need to change the mode to delete disconnected. Oh, sorry, delete connected. But that does give you a cool visual of the way it's finding the boundaries. It's delete connected. If we save that and go back into our render stage, there, you can see now that we have nice clean bottle. It's not pre-fractured and there's no render errors. So that's how you fix that. Back into the material library. After this, I'm going to come back up into the specular, which obviously controls how reflective it is. And I'm going to change the color in the specular to like a kind of like a brown, like beer bottle kind of look, like generic beer bottle. I'm going to copy the hex code so I can put it into the other ones as well, into the transmission. And put that there. There we go. And now you can see we've got like this kind of generic brown beer bottle, and you can change the specular color of it as well, like with the reflections. I'll keep it as brown. I'll just make it a little bit lighter. There we go. And I'm happy with that. Again, there's going to be no close-up of this, at least in mine, so we don't need to worry about that. I'm losing the bottle a little bit. There we go. There we go. Deselect that. So that's basically all I did for the bottle. Nothing crazy. If I had a close-up, then you would do surface imperfection, some roughness, and you can play around with these as you want. If you come from Blender like I do, most of these will be pretty simple to you. You'll know these. You've got the roughness, index of refraction, which you can set. All you have to do to find the index of refraction is just look it up on Google. There's a wonderful resource for it. So there's this wonderful list called the Pixel and Poly IOR list, and it has the index refraction of most reasonable materials, and it is sorted by alphabet at the end here, at the top here. So if we want to find glass, we'll just have to go to G. I'm going to do Control F here and just type glass, and you get all the different types of glass: acrylic glass, glass, Pyrex, everything like that. Flint glass, heaviest flint glass, like you get crazy things. So the IOR of glass, which is the index of refraction, which determines how light bounces around through it and gets refracted, is 1.500. When we go back into Houdini, we'll see that the default IOR is 1.5 anyway. So we can leave that be. And honestly, I'm just going to leave everything else be as is in here anyway, because like I said, this bottle will be on screen for 1 second before it's smashed, and we're not going to be close up to it. So I'm going to leave that alone. So next we're going to do the cloth fire, just because I'm looking at it right now. So I'm going to do a Karma Pyro material, and I'm going to do a Karma Pyro fire material. And I'm going to drop that down, and I'll name this smaller fire, or cloth fire. Just in case I want to have slightly different settings for each fire, it's nice to have that control. So I'm going to hop in there. I don't want it so disorganized, so I'm going to press L to organize that. We're going to go into the Karma Pyro shader. And remember, we need to go to the stage and assign it. So, new material, select the geometry. In this case, it's this little fire. And then go in here, into the material library, and find the one you created, so cloth fire. So make sure to assign that so you can actually see the changes you're making. So I'm just going to turn off the grid so I can see a bit better there. So you can see we've already got some kind of something going on there. So we're going to change that. So we don't need smoke. Smoke is enabled already. We can disable smoke. And fire stays enabled. You can see we've got some kind of fire here. Let me move it up. You can see the motion blowing effect there as well. But I'll do it from here. This fire isn't super accurate or contained. I feel like the Molotov would have gone off already, but that's okay. We're going to change the intensity scale. That's about something like 50. Maybe not 50, like 25. We'll adjust this. And what I'm going to do now is I'm going to change in the bottom right here from auto update to on mouse up, which means the viewport won't update until I release the left mouse button, which just means we can manipulate this graph without it lagging. Because if we have it on auto update and we start changing this graph, you can see it is updating every like second, and it makes dragging it around slow. So I'll do it on mouse up, and then we've got free roam of this graph, and it won't update until we let it go. So what I'm going to do here is I'm going to change the source, I'm going to change the fire intensity ramp a little bit to my liking, and it looks something like this. So I just click, drag, and at the end, click, drag to the end. That's a very basic setup for having what I think is a fairly decent fire shader with like real minimal work. All we did was change this. And I haven't even changed the source range yet, so I'm going to color it a little bit at the beginning. I'm going to do 0.3, and I'll cut some of that unnecessary, well, I say unnecessary, it's completely up to you really, and your reference, but some of this like fluffier fire, so we have a sharper fire. So cut like maybe, so 0.2, and then you can also do it the other way, so you can do like 0.9, but I'm going to leave the top end as is, and you can see I'm pretty happy with that. You can cut it even more, but you know what, actually I'm going to do like 0.45, and I'll go back through that. You can see that's looking a lot better now, and I'm going to have to increase the, oops, I keep sending the bottle on its way. I'm going to have to increase the intensity a little bit so we can get some more of that up. 250 is pretty bright. You can also change the exposure on your camera, but maybe 125. 125 feels okay. Again, you can change the exposure on your camera, but that is, I'm pretty happy with that, with how that looks. Yes. So next, we're going to change we're going to create a pyro shader for the big fire, and we will just duplicate this one and then make some changes depending on how it is. So let's go back out, and just for easier selection, I'm going to turn off the smoke. So find your smoke stop import, and then this little yellow arrow, just click that and it'll disable it temporarily. So I'm going to make a new material, right there. You can also just add a new material right there. This just adds one above the last one. It's the same thing. I'm going to select my fire, and then I'm going to go and create a material, which I forgot to do. So I'm going to duplicate this and name it fire. Oh, big fire. And I'm going to hop back out to that, and I'm going to assign that big fire. And even though we've got the exact same settings, you can see it looks way different. So that's why it's good to have the separate control. So I'm going to go back into the big fire, and bear in mind that you will have smoke on top of it. So it's probably best that I show you it with smoke. But for now, we'll just do the big fire. So we're going to go back in here. I'm actually still pretty happy with the graph. I'm just going to change this down to like 20, 15 maybe. And then adjust the graph a little bit and move this along. And where this is on the graph will affect the look of the fire. So if you select this left one and then hold shift and select the right one, you'll get all of them, and you can just move them along. And you can see you get a slightly different look of the fire wherever you have that. So I'm going to drag this over here a little bit. Drag this over here a little bit. Have this up like this. I'm just going to play around with it until I get a look that I'm more happy with. Good stuff. Right, yeah, tweak this to your heart's content. You could be on this graph forever. You can change the interpolation mode if you wanted something like, oh, not like that, but like B-spline or something like that. You can change the interpolation however you want. It's actually not bad. So I might leave it like that, but again, up to you. Another one that we could be here forever tweaking. And you'll see the exact graph I used for the project file in the description. And then you can also change the color, of course, here. I typically change the color of my fire or tweak the tones of it in post. I just have more control with it. But you can change it to black body as well, and then, you know, set like a temperature, and then maybe not one that high. There we go. You get the idea. So if you want like a warmer fire, you can use the black body temperature, or again, just tweak the color ramp yourself. But I like to do it in post, so I leave it alone. Now we're going to do the smoke so we can give this a bit more volume and see what's going on. So I'm going to go to material library, type in a Karma smoke material, Karma Pyro smoke material. I'll drop it up here. And I'm still on the mouse up, but that's fine for now because we're doing a bit more tweaking. Actually, I put on auto update so I don't forget. And I'm going to just name this smoke. And you know the drill. Back up, new material. Let's turn the smoke back on. I'm going to zoom out a little bit. You can already see, even with the base normal material, that it gives the fire so much more volume. And then we're going to go in here and select the smoke, press enter. And then we're going to give this the smoke material. And let it initialize that for a second. It will be noisy for a sec, and then it'll be all good. So I'm going to hop back into this, and the smoke material I'm already pretty happy with, but we're going to do some adjustments. Go in here, hit L to organize everything. And then this is where you can play with your density scale. If you want that nice, thick, rolling fire, which is quite nice. You can also use a ramp as well. Some people will actually go back to my mouse up. So that it can be thinner at certain points and thicker at other points. So if we move this ramp like that, you'll see that it kind of expires quicker, and it's the same the other way around. If we do this, then there'll be less smoke kind of where the fire is, where the fire starts, like so, which can give you interesting effects. I do think it's worth playing around with the density ramp. You can get some funky effects. And in the project file, I did indeed do that, but I'm not going to do that right now. So I'm going to change the density, and the color is actually fine. It's getting a lot of color from the environment lights. So I'm going to go back out to run the stage, and change these colors, a little bit. This is meant to be like the sky backfill. So that one is fine. This one is perhaps got too much saturation. So I'm just going to lower the saturation on that. There we go. And then now the sky is shining through too much. All this area light, distant light is shining through too much. So I'm going to lower the saturation on this a little bit as well. There we go. And then you can always increase the intensity of these as well if you want to see more. Play around with the exposure of these, stuff like that. That's quite a nice backlight, honestly. The exposure on the distant light. So I might turn that up like a little bit. And then desaturate that a bit more. There we go. And I'm pretty happy with that. You can also, of course, rotate these. They have transforms. You can rotate them. You can turn the transform view on, so you can rotate them, but I'm not going to do that. So I'm going to hop back into the material library, and I don't like how dominant it is at this stage of the simulation. I think it's actually too strong at most of the simulation, and I think the smoke is too light. So I'm going to make the smoke a bit darker, like so. There we go, that's a lot better. And then I'm also going to just lower the density. It's a shame when you make a smoke sim and then you can't have it really thick, because you know, you get all that cool rolling detail in the in the disturbance and stuff like that. And when you're at density 1, you don't get to see that. But if you look at reference to Molotovs, the fire is not really all that thick. But I mean, if you're just doing this for fun, who cares? You make the fire as thick as you want. The smoke as thick as you want, sorry. But I'm going to keep it. But I'm fairly happy with that. I, as you can tell, will definitely do a lot more tweaking to the smoke. But for now, I'm just going to leave it be. I'm fairly happy with it. But that's basically it. In this camera view I'm in now, I don't know why this is in edit. There you go. Tell you that. In this camera view I'm in now, it is well, not camera view. You come to the settings view, you'll see that is in 1280 by 720. So that's what you'll see in the camera. So you can see it looks a little low res, and that's because it is. But if I come out with the camera view, you can see that it's all the details there. So if you want it to be higher res in the viewport, just you're gonna have to change this to like HDTV 1080, which will of course increase render time. So for now, I'm gonna leave it on 720. And there's a few things I'm gonna change in all of these settings. So in the camera settings, render settings, I'm gonna change this to XPU because I'm using XPU to render, and I will change it in the USC render up. And this is basically your samples. I'm gonna change this to like 64, just because I'm doing this for speed. If you're doing this for quality, final render, then obviously you're gonna want this as high as you can while maintaining a reasonable per frame render time, because you don't want to have this rendering for like 5 days. So with my GPU, which is quite fast, this is going to be really quick. It's probably going to be like a second or less per frame at 720. So that's fine. The camera is auto selected. If it's not, if you have multiple cameras and you want to change angles, make sure to change your camera here. This is the output name. We'll worry about that in a second. And this is where it's getting the render settings from. So no worries about that. And then you have a bunch of settings here, which we're not going to go over all of them. What we're going to make sure we have is that we have camera effects, velocity blur turned on, so we can affect the fire, stuff like that with the velocity blur. Motion blur, if you don't want it, of course, just, you know, turn it off. I will be using it, so I'm going to turn it on. And then denoising is another thing that I'm going to want to use. So I'm going to go ahead and find that. I'm actually going to search for it just up here. Denoise is under image filters. So I'm going to go ahead and click. I'm going to use optics, because optics on my card is much faster. Intel OIDN is open image denoising. And I've heard that its quality is a bit more consistent, a bit better, but it is slightly slower. And right now I just want speed. So that's what I'm going to go for. And if you don't want to search up, that's where it is, image output filters. And then you've got the denoiser. I always lose where the denoiser is. And you can see in the viewport it's taken effect. Obviously this is low res, so it looks a little crusty. But if you make it 1080, you'll be a little bit faster, or a little bit higher res, and then increase the samples. But you get the idea with the samples and the resolution. You know how that works. And then you have your tone mapping as well. If you want to do all of that, you've got aces, you know, all of this good stuff. You can do whatever you want here with the tone mapping. Again, I just do it in post because it's a lot more flexible. I don't have to bake it into the render, but you've got all that good stuff there. So after that, I'm going to scroll down to the USC render up down here. I'm happy with the current take. Render the whole frame range, current frame. Right now it's just on current frame, sorry. But when you're on the animation, you're going to want to do specific frame range. And I'm going to go ahead and take render all frames with a single process. So what it's going to do is it's basically going to load in all of the data it needs to render in one pass, and then it's going to render the actual image in another pass. And I just find that I think it should be ticked by default. It's a lot more of an efficient way to render. Now you've got that set up, you've got your material set up, everything, you're happy with everything. The motion blur, the camera is perfect, the lighting is perfect, which is a reasonable expectation. You have two ways. You can render it to a disk, or you can render it to mplay. What I typically do, just to make sure my settings are correct, is I'll go to a random frame, make sure it's on the current frame, and then I will render to mplay for just one frame. So there you go. There's my one frame. The reason I render this to mplay in this situation is because I just want to make sure that everything's good, my lighting's good, my framing's good. But I don't render my entire animation to mplay. And the reason I don't do this is because if mplay stores this window in RAM, it's not saved on the disk. So if your computer crashes or you close this window by accident when the render's done, you will lose the entire render. There is absolutely no way for you to get it back at all. So please keep that in mind. If you want to render to mplay and gamble that's on you. I think the best way is to do a preview render with render to mplay for a single frame, and then render to disk, as like an EXR or something. So that is what I would recommend you do. So I'll show you how to do that. So I'm going to go back, close that mplay window, send it to the void. I'm going to go to render specific frame range, and then up here on the render settings, this is where you choose where you want it to go. So I'm going to go ahead and click open floating file finder, and we're going to find somewhere for it to go. So I'm going to just make a new folder here called SQ for sequence, and I'm going to name this something like I'll just name it Molotov, and then we're going to do $F, or full stop $F. $F just means frame number, so it will be an image sequence, and then .exr, which is the file format. You don't need this full stop before it. It just kind of makes it easier to read. You can do an underscore if you really want, but I'm just going to do a full stop. And then I'm going to press save. And then once that is all set, you're happy with all your settings, and you'll come down to the USD render up. So here, go ahead and click render to disk. You'll get a little window pop up. And if you go ahead and check exactly where you set your output to be, you'll see that there's nothing there yet. And that's because it's not rendering yet. It's doing the process beforehand that I mentioned. So just let it do that. Go make yourself a cup of coffee, or in this weather, maybe go get yourself some nice cold water and let it do its thing. And we'll be back when it is done and rendered. So that's basically everything you need to know about how to make this kind of effect. This was a longer tutorial. It could definitely be a lot shorter, but there's a lot of techniques I wanted to show and explain exactly why we did them, rather than just do a speed run and show you what to put down, so that you can apply these techniques to other simulations. It might not be Pyro, but that's about it. I greatly appreciate you lending me your attention. If you enjoyed the video or found it useful, please like, subscribe, and check out dammydigital.com/merch, and have a great day.